Nikhil sir, is this you with the name administrator? Tuhini ma'am, am I audible?
Yes, ma'am.
Okay. Nikhil sir, is this you with the name administrator? Dr. Nikhil Mariwala, sir.
Ma'am, I hope you're able to hear me.
Yes, yes, sir. That's why I'm asking.
Oh,
Okay, Nikhil
I
sir.
was
you have
unable
time.
to unmute actually.
Yeah, I have given you the rights now. I will
Right,
make,
right,
I will
right.
make you the co-host.
Okay.
Yes, sir. Give me a second. So shall we start the program?
Yes, ma'am, please.
All right. Thank you, sir. Good morning to one and all present here. I, Priyanka Saxena, welcome you all in the another session of 1 week online AICT Atal faculty development
Ma'am, ma'am, your voice is not clear.
Madam, your voice is unable
It's
to hear.
breaking.
and its application is working as a
Ma'am, your voice is breaking. Please start again.
Am I audible now, ma'am?
Yes, ma'am.
Okay, sorry, so there's some network problem at my end, that's why. Sir has published more than 35 papers in reputed journals and 20 papers in national and international conferences. He has filed 7 patents, 1 in India and 4 in international patents. He has addressed as a keynote speaker in various national and international conferences. He is having an additional responsibility of TNP officer at UIET Kurukshetra. He is the reviewer of various national and international journals, and he is the single point of contact of NPTEL SWAM at UIET University. He has been also awarded as the NPTEL Enthusiast for year 2019-20 by NPTEL IIT Madras. His area of interest are soft computing, wireless communication, fuzzy system design, advanced microprocessor, sensor networks, etc. Sir, I, on behalf of SoIT-RGPV, welcomes you all in this faculty development program, and thank you so much for accepting our invitation, sir.
Thank you very much, ma'am. I hope you're able to hear me clearly.
Yes, yes, sir.
So thank you very much for firstly for inviting me over. I'm thankful to all the organizers of the FDP program to have invited me. So big thanks to Mr. Mishra sir for having asked me to give a talk on this particular FDP, and I hope that today's talk will be of some use to all the participants who have been attending this particular program now for a few days. I would wish that the same scenario would continue as far as this lecture is concerned. So thank you very much, and welcome to all the participants in this particular talk. I would, ma'am, I would just like to know a few things before I start. Have you allowed the participants to unmute themselves, or it is just they can chat?
No, sir.
So they can chat also, and they can unmute themselves also.
Okay, great. Because if I ask a few questions from them, it will be a point. I just wanted to know whether they'll be able to switch on their mics or not and talk to me.
Yes, so they will be able to do both.
Okay. Okay, that's great. So now, ma'am, if you allow me, I'll just switch off my camera and then I'll share the screen, right?
Sure, sir, sure, sir. So I have given you rights of co-host. You can share also your screen. Yeah.
Right.
All right.
So I hope you're able to see my screen, ma'am.
Yes, sir. Your screen is visible.
So I don't know whether this message would remain here or it will fade away.
Yes, sir. Your screen is visible. Yes.
Ma'am, do you know some way to hide this out?
Sorry,
Okay.
sir, you're not audible. Please,
Okay,
pardon.
okay, I got it.
I have done it, sir. You can continue, sir.
Right, sir. Thank you. So a very warm welcome again to everybody. I was just worried about the screen coming on. So we'll today talk about the blockchain and its applications, as you can see it over here, right, in IoT. And today's talk, I will try and highlight and explain the advantages of the blockchain first, and then I will try to incorporate the usage of blockchain in IoT. Right. I hope. So I hope you will be able to just do let me know if there is any problem in the voice from my side, right? If any, because I will not be able to see anything.
Yes, sir.
Sure, sir. Sure, sir. We'll let you know if there is any problem.
Yes, ma'am. Yes, ma'am. Right. Thank you very much.
Yes.
So as you can see, what we have is we have a slide over here where a person is calling out, and you can see very well see that the point over here is that we have written tried to write few things over here, and the things suggest that this person is trying to highlight few aspects, that this is basically I'll just use the pen over here, just a second. Right. So a fintech bubble, a domain of fraudsters and crypto culture, nothing to do with education, Bitcoin hype, governments are making this illegal, and let's wait for the future. Some of the points that are here must be very familiar to all of you these days, because there is a lot of talk about blockchain around us, right? So if you see what we have highlighted over here are few aspects which everybody wants to know, right? And everybody understands this concept of blockchain with the help of a Bitcoin hype. I hope you understand when I say Bitcoin hype, right? Everybody understands this. So in few days from now, you will see the parliament session opening, and you will see a bill most probably being tabled on cryptocurrencies and its usage, right? So this is one of the aspects of blockchain technology, but this is not the only aspect, right? So this particular talk that I'm giving you today highlights that what we are having is a very simple structure over here, and which is dealing with only Bitcoin, right? But this is not the case. This is not the only thing, right? So that is why I've just written Bitcoin hype over here. So when I write Bitcoin hype, what I'm trying to say is that this particular scenario is basically in some situation where Bitcoin is the only answer to blockchain, right? And there is one ad these days coming around where the actor says it is a bubble, hawa, right? So yes, that is why I have written this as fintech bubble over here. Domain of fraudsters and crypto culture. This is what many people fear, right? But this is basically not possible right now to highlight this aspect, domain of fraudsters and crypto culture, and nothing to do with education. Now this is very interesting, right? A point which highlights that this particular concept has nothing to do with the education sector, right? So if it has nothing to do with education sector, then why we are talking about this concept in future world, and what is the scenario, why we are referring to this as one of the upcoming technologies to be utilized. AICT is also laying so much stress onto this in the form of emerging areas, right? So you can all very well see that these are some of the apprehensions that everybody today holds, right? And this particular talk, I will try and highlight or just ensure that you are familiar with the major concepts of the this particular aspect, and then I hope that we will be able to resolve some facts out of this, right? So I move on to the next part. 2016, right? If you see this particular slide over here, the slide talks about years, blockchain for social good and blockchain technology, right? I hope you are able to see this. I just for 1 sec, I'll just ask it. I hope the slide is visible.
Yes, sir.
Yes, sir.
Great, great, great. Now, if you try and see this particular aspect, what you see is what you are able to see is in 2016 and 2018. So we have, I've just taken these slides from European Commission, right? So digital market and blockchain technologies for social good, and EU blockchain observatory referring to certain aspects over here, right? So what we are talking about in this case is that EU or the European Union, the Commission launches the EU blockchain observatory and forum. Now see, Europe, as you all know, is one of the leading possesses one of the leading countries in the world, right? So these countries have formed basically European Union, right? Where they are working about launching of blockchain concept in education sector, right? So we are talking about education, we are talking about IoT, we are talking about different concepts being utilized through education, right? So now this is very, very interesting concept, and I hope that you people would agree with me that if we have transparency in any of the system, that system basically is one of the best systems that anybody can provide us around us, right? So if this transparent system comes into picture, then it is very good for us, right? So on the similar basis, this article was published by The Guardian, that blockchain so much bigger than Bitcoin. Now try and remember these words, right? The very first slide was talking about Bitcoin hype, and I am talking about an article in The Guardian that blockchain is so much bigger than Bitcoin, right? I don't know how many of you still know the concept of blockchain, or how you people can use this effectively, right? But what we are referring to here is a new technology of trust, right? So this is what I wanted to talk about today, and we will try and make sure that you people understand this particular scenario, right? So blockchain basically is the new technology of trust, and technology is what this particular technology is redefining the way of transactions, right? Or it sounds incredibly far-reaching because of its qualities, right? I'll be discussing them one by one, and we will be highlighting all these things very effectively in our talk today. And I'll try my level best that you are participating in this complete talk that we have, right? So what blockchain combines is, I've written over here, it combines the openness of the internet. Now remember this word, openness of the internet, because internet can be accessed by anybody and everybody, right? Whosoever is having the access with a particular network can connect themselves with the internet to make sure that they are connected with the information, right? Internet with security of cryptography. Now this is very, very interesting concept, right? Internet with security of cryptography, and it is very fast, right? There is a key of information to establish the trust. So that is why we refer this technology as technology of trust. Now earlier I had shown you in this particular slide that domain of fraudsters and culture. But it is not so, right? Everybody who is using Bitcoin or who's dealing in Bitcoins is not a fraudster, he is not a gangster, he is not from the gray market, right? The main important concept of blockchain is transparent system. Now, I again repeat, everybody who is in power is afraid of this culture of transparency. If this culture comes in, then what happens? I don't know whose mic is on, but anything you want to say? Anybody wants to say? Ma'am, if you can hear me, there is some mic on, and you can ask the person to switch it off if there is no confusion or there is nothing the person wants to say in this case. I hope you're able to hear me.
Yes, sir. Yes, sir.
Yeah, please, if you can request that person.
Yeah, I have muted him.
Okay,
Sir.
okay. Now see, what we are referring to here is the blockchain introduction, and I'll be trying to introduce the concept to you. I've given you why we are talking about this and why everybody is discussing this concept and why this FTP chose this article on blockchain technology and why we are referring to all these things. There are certain answers that we needed to give, right? So this is basically something that we want to understand over here, right? And tracing the blockchain's origin, the shortcomings of current transaction system. Now, if you see this particular chart during the 2000s financial crisis, now this is what we have seen, the records over here that we have, and then we are talking about some structure which is centralized, right? So I hope you understood or you followed why we are talking about this centralized structure. We are all into this, right? So we are into a structure which is basically centralized, which is being controlled by a central authority, right? And we want to do what? We want to make sure that this particular scenario remains such, right? So those who are afraid of the centralized culture are the ones who are making sure that there is basically something which is not given to or which is not basically available to all to see, right? So I'll just try and explain this to you. For example, if I delegate the power to all of you, right, to perform a particular task in your college, right? So everybody has the power and everybody's consent is very necessary in that case. Then what happens? What happens? How many of you feel that this particular thing would be beneficial? I've delegated the power to all of you, and what I'm trying to do here is I am trying to make sure that you people, your consent is required to perform certain activity in the college. So everybody's consent is required. So how many of you feel that this would work? I don't know. How many of you feel this would work?
Centralized.
It is decentralized right now. Decentralized means everybody is having a power, everybody has a control, and everybody's consent is required to perform that particular thing. So how many of you feel this will be a good idea?
It can work, sir.
It can work, right? That's great. I'm still trying to gauge out how many of you feel it would work. And is it a good idea to delegate power to everybody? I don't know. I don't know. You're still confused in that case. So I'll just try and explain this to you in this particular scenario. This is basically a chart where shortcomings of current transaction systems have been highlighted. The point is that normally whatever you do, you store something in the form of a ledger, right? So the ledgers are basically books where entries or datas are recorded. Now, these entries are basically controlled by someone who is in central control. Now, he is the person who can manipulate these entries on its own, or even change it, or even remove it, right? Because it is at a centralized structure over here. Similarly, each thing works, right? Say a bank. So, bank has a server, and normally you see these days, you hear these things very often that a particular hacker tried to access the put down the server of a particular bank, say a server of the NASA or server of CIA, right? So because they are centralized, when they are centralized, then that is a big problem, right? If we try and decentralize these things, the records are maintained by all the parties, then what happens, right? So the record which is given to one point will be copied to the other point. Similarly, the auditor is copying the same part to the other point. All the ledgers hold the same entry. Now, if the ledgers are holding the same entry, then what happens? It is very difficult for anybody to do what? Anybody to remove that entry, because he has to remove the entries from all the ledgers. Say 100 ledgers are there, so it is not possible. I'm just taking a small example, 100. It can be thousands, it can be millions. So banks have lakhs of entries daily, right? So if those entries are stored at every point, then it is very difficult for a person who is trying to hack into the system to make sure that he has an access to all the ledgers. He will never be able to do that, right? So on the similar basis, this particular paper by Satoshi Nakamoto was published, which was called as Bitcoin, a peer-to-peer electronic cash system. So he was the one who gave this concept in the very first part, right? So this is the white paper that everybody should read who is interested in dealing with the blockchain concept, or even understanding how Bitcoin works, right? So this is the first concept introduction by Satoshi Nakamoto, and it is available on www.bitcoin.org, right? So he gave this particular concept. Now, on the basis of this concept, many digital currencies came up, right? And most successful of the lot became Bitcoin, right? That is why we have been talking about this a lot. So this replaces what? It replaces cash with numbers and codes. So what is the biggest advantage of this particular currency? I don't know how many of you have been witnessing some programs these days on news channels coming, especially on Bitcoin, right? Why they are highlighting this? Because everybody is talking about it, and everybody wants to know or be a part of this, right? So why so? Because this is fast, internationally acclaimed or internationally approved, right? Easy accounting, weighs nothing, very cheap, and there is no transaction cost. Very interesting. There is no transaction cost. Now, the point that I want to highlight in this case is, because this is digital currency and you can transfer it to somebody that you want, there will be no transaction cost involved in that. Say you transfer some money from your bank account using internet services, say a UPI app, or say the internet banking or some other platforms that are available. There is some charge levied on us, right? Some apps are not doing it, but many are doing it. Banks are definitely doing it, right? So this transaction cost becomes zero as far as digital currency is concerned, because this is already digital. It is in 0-1 format, and it is very easy to transfer the same thing, and the records are immutable. So you will always come to know that this Bitcoin has traveled from which place to which place, who was owning it earlier, and who is the owner right now, right? So say, for example, again, I repeat, somebody knows how much Bitcoins you have. Is it good for you or is it bad for you?
it will be bad, sir.
It is bad. Now, why it is bad, ma'am? Why bad for you?
So then there is also a security problem because
There is no security problem. I'll tell you about this, but somebody is just knowing the information that you possess these.
yes, sir, because of that it is a security problem. Like we always
Okay.
get these mails also.
Okay.
Pay in this bitcoins or we will block your laptop or things like that.
Right. So you have experienced this kind of a scenario.
Yes, sir, many times.
Right. Similarly, if I am a person who is in power and who wants to who enjoy some kind of a leverage for me, and everybody knows that this particular minister or this particular celebrity is holding 200 bitcoins with himself, then it will be a big problem for him or her, right? I hope everybody agrees with it. Because see, first of all, it will be difficult for him to justify how he bought it, and because this is not legal as far as the country is concerned right now, how the transactions were done, and from where the money came and where it went, and how these things are moving around, right? So this can be a problem, but this is not actually the problem. We are looking into a very small aspect of the digital currencies. See, if this would have been the case, country like ours would have never thought about bringing a digital currency into the market, right? Because we are dealing with some digital aspects. It doesn't mean that anybody can have an access to it. This is very secure. I'll tell you in the future slides that why Bitcoin has become so much popular and why this particular thing is holding this ground still, that everybody is running after this particular market, though there is a huge slump today. You can see last 2 days the currency has gone down by almost 2% to 3%, right? I might be wrong. The data may be corrected. We can see it right now on Google also, right? Now, what we are referring to in this case is problems of digital currency. As everybody highlighted, what are the problems, right? So we'll just try and identify that, and then I'll tell you why and how IoT comes into picture with blockchain, right? It is a perfect copy, just like downloading attachment from an email. How to distinguish between counterfeits, that is what is the major issue, and ownership problem, right? Double spending, that is networks are noisy and transmission across networks is far from instantaneous or delayed network. Hackers can capitalize. Now everybody is worried about this, right? Everybody is worried about this, as if out of 3 persons, 2 are always hackers, right? Or fraudster detection problem is always there, right? But these are very small as far as the digital currency structure is concerned, right? Anybody can say that bits are very easy to copy from or hack from or use from, right? But this is actually not the case. As far as this digital currency is concerned, all these myths will be gone once you see what I'm trying to give you over here, right? So the long road to Bitcoin, this is what is the next slide talking about, the long road to Bitcoin. Now, long road means how we will be establishing the structure of Bitcoin over here, right? So centralized banking, as I was talking about, this centralized structure of banking is basically not robust, and Satoshi Nakamoto determined to find centralized part of banks, right? So what was so important that the centralized structures were required, right? Why were they so important for any bank? Why centralized structure, right? So he tried to find out, and I don't know how many of you are visiting the banks, but you still see the ledger. So this is one of the most important part of the bank, right? Ledger. So what if I could turn a bank inside out? He asked himself. Instead of one central party, just try and listen to this statement. This is very interesting, right? Instead of one central party controlling this ledger, what if every user recruited is maintaining a constantly updated copy of the same ledger? How interesting. Now the cashier is receiving the input or the cash and is updating the ledger in the computer, as well as the same thing is being copied to all the other systems who are connected with that particular area, even the other parts, and the consumers are also getting to know that this kind of a transaction is happening, and they also be a party to it, right? So this is what he thought. The strength of digital was perfect copies. Now this is very, very important concept, right? So copy the ledger everywhere, he said, instantly at the same time, right? Copy the ledger everywhere. Any ledgers with even one common not agreeing. Now this is what I was trying to tell you. Even one common not agreeing with the masses, that particular entry would be discarded, leaving the fraudsters powerless. I hope you have understood what he thought and what concept he wanted to give. Any questions up till here? Any questions?
No, sir.
Right. So the important concept was replace cash with ledger. Right? The important concept was replacing cash with
Yes.
ledger. Now, this is a very new thing, very interesting thing. Cash can be replaced with ledger. Now this is the ledger, this is the register. I hope everybody has seen this. Most of us are maintaining them for our daily entries. Now say for example, I want to do some manipulation in this particular ledger. What I'll do? I'll make sure either tier of the page, make this entry, cross this entry, right? And see that nobody is able to look into what I'm trying to say, right? Or make sure that I hide this from everybody and I just tell them, yes, I was doing this, and this is what I've told you, right? So you can all look into this. Now this is what he thought, that if this register would be common. Now can this be common to everybody, and can these entries be common to everybody? So again, a very new concept, very interesting thing, and this is what he was talking about. This is the concept, decentralization, right? Replacing cash with ledger, that is centralized system replaced with a decentralized system, and distributed ledgers. I hope you followed this.
Yes,
So
sir.
centralized and decentralized. Now what is happening? Central power is gone. Everybody holds the same ledger, and each one who is linked in this particular chain has to give a tick. Now tick means what?
That the entries are correct or are
That yes, that the entries are correct. Very right, ma'am. And all the entries are valid, right? So I can use a word valid over here. So these days, do you see any tick somewhere on some of the social media that you use?
verified in Twitter and
Yes,
in
yes,
YouTube
yes,
also.
yes, yes. Or a blue tick on Instagram, right?
Yes.
Now, what they are doing is they are verifying your profiles.
Sir. That the
Right.
original person is not faking.
Yes. Now, do you actually give your personal details in that, or is it uncomfortable for you to make sure that that blue tick is received by you people? Is it so? I
Sir,
hope.
it is if we don't know how to mask our personal information from everyone seeing, then it will be very difficult.
Then it becomes difficult, but they are not using it from anybody, right?
Yes.
No, I hope you understand how safe it can be in that case if somebody wants to make it safe. Isn't it?
Yes, sir.
Right. Similarly, if somebody wants to leak it, it becomes very easy because it is centralized. Now, these systems that we are using right now are centralized structures. Facebook, Instagram, Twitter, all are connected with internet, which is again controlled by somebody with a central authority. I hope everybody understands this, right?
There are always news of that data has leaked.
Yes, data is being hacked or data is being used. Facebook is
Or
facing so many
information
legal,
is out.
yes, Facebook is facing so many legal battles, and these are some of the things. Now, because of this centralized system, each of these problems will always persist, right? But if I make this system decentralized, then these problems fade away very fast, right? You'll see that these problems will never or cease to exist. The things that we are trying to hide upon, or we don't want to make our public profile, we want that information should be safe. Everything is visible, right? You can make your profiles, hide your profiles, but still the things can be seen. And if they can be seen, why not? Why not make sure that we people use a system which shares the things easily, and also is not leaking our information somewhere where we are uncomfortable or where that information should not be used, right? So the new networks talk about distributed ledgers that can be public or private and vary in their structure and size. The public blockchains are very interesting and very, very important concept, conceptualized for these kind of transactions. These require computer processing power to confirm the transactions, which are called as mining. Now remember this term, right? So you must be hearing these things, that you have to mine the cryptocurrency, right? So the mining part is the one that is what you people need to work about, right? Then if you see, users are anonymous. In this case, users are anonymous. We are talking about distributed ledgers. Each user has a copy of the ledger and participates in confirming transactions. This is one case. In this blue case, permission is required for user to have a copy of the ledger and participate in the confirming transaction, right? So both these cases can be utilized. Now, this is the case of distributed ledger, which is using this decentralized structure. I hope you have followed this. Now, there can be a public blockchain and there can be a private blockchain also, right? Do you get this now?
So I had a doubt.
Yes, ma'am, please tell me.
Sir, like you said that if consumers are made a part of this process, like distributed network,
Right.
then
right.
will the consumers see all the transactions which are going on in the bank? Like right now, the consumer is able to see his own transactions,
Right.
but he is not aware of what is going on in the other areas. So in that case, will he be able to see all the transactions of the bank? And if so, how is he able to confirm whether the transactions are right or wrong, whether the entries are made right or wrong? Like he can confirm for his own transactions, but
Right.
then how he is going to do it for all the other transactions?
You're very right, ma'am. After this, I'll just answer this particular thing only, right? See, now as far as banks are concerned, it is a complicated process if we involve everybody, right? Now, the point again, what we want is, we want to make sure that the power is decentralized and there is no centralized authority who is actually controlling and manipulating things whenever required by them, right? So the very first thing that has been done in this case is, in blockchain is, you need to first select whether you want to be a part of public blockchain or a private blockchain, right? If it is public blockchain that you are a part of something, then everything is visible to everybody, right? Also, he or she has to verify the transaction. I'll show you how. Like you are a party in a particular chain, and everybody says, the person says that I have this type of transaction to do, or I have done this type of transaction. Kindly approve this, right? So whatever transaction he says, you believe that, and then you process a tick. I'll show you how this process is done, right? Similarly, there are transactions to whom I don't want, I don't want everybody should know about that, but yes, transactions still happen, right? That transaction record will be there, but who has dealt with whom and on what basis, that is not actually shown to everybody, right? So both only the parties, I should write here parties, only the parties who are actually part to that particular transaction will come to know that this they are doing what deal, right? But yes, everybody will still come to know that some entries have been made in A to B parties, right? The ledgers will be made available, right? In that case, that those ledgers will never be wiped off or cannot be changed. I hope you got something. I am still into very basic idea.
Thank you, sir.
I'll just introduce it again further when I move to the next slide. So decentralization got what? It got rid of the third parties, right? Satoshi paired two main technologies, that is proof of work and elliptic curves, right? So proof of work was to solve double spending problem, and elliptic curves was what? To solve uniqueness, access to the ledger, right? So nothing was newer till 2001 for anybody, right? Everybody knew these things can be done easily, and we were talking about this in some way or the other. So I'll just take you through the history part. 1980 public key crypto algorithm, 1991 cryptographic timestamp, proof of work came into 1992 to 93, right? Similarly, 1997 hash Nick Sabozi 1998 talk about bit gold, B money, P2P networks, right? Byzantine fault tolerance, right? And then SHA 256 was the one in 2001, right? So these things were already there, but he tried to do what? He tried to incorporate everything together into one concept, which was talking about something related to blockchain structure, right? Now this is very interesting how he did it and how things became so popular as far as the Bitcoin is concerned. What is blockchain technology? So I'll give an example with Bitcoin only. Bitcoin stores all its transaction onto public database called as a blockchain. Remember this, right? So that is why governments who are trying to ban this particular currency are looking into the aspect there that their control would be lost, right? Because this is a chaining concept, everybody is linked with each other. Whatever transaction a government even does would be also visible to everybody. Say, for example, I come to know that the petrol today was bought at this much barrel, right, by the government. When it reached to the country, the barrel cost reduced, and the next lot was bought at this much barrel. Every day I come to know, and when I compute it, I come to know that I've been paying almost 3 times to 4 times, right? So that will be bad. That will be bad. So if I lose the central control in some of the organizations, it is not good. And that is why this concept has become a problem for many countries who are under some rule where central control is very, very important, right? So they have banned it. Many have banned it, right? They don't want anything of this sort to come to their country, so that their currencies or their transactions are known to anybody, right? So in any case, blockchain technology, not only related to Bitcoin, but I'm just trying to tell you what it does. It stores all its transactions onto a public database called as a blockchain, right? So a chain network has to be there. Now this is how it works. Just have a look over this scenario and you'll be able to identify this according to your own aspect. If you see someone requests a transaction, right? The very first part is someone requesting a transaction. So if someone is requesting this particular transaction, then what happens? The next step is, if you can see over here, the requested transaction is broadcasted onto what? It is the requested transaction is broadcasted onto P2P network, right? I hope everybody is able to see this. You're able to see this slide?
Yes,
Yes,
sir.
sir. Yes, sir.
Right, great. So this is a P2P network consisting of computers known as nodes, right? So we all know this P2P structure, right? Validation, that is the network of nodes, validates the transactions and the user status, because everybody is aware that yes, this user exists. Now you don't have to tick the transaction. You have to tick what? Yes, this user is right. User is fine. Now, do you understand this? Right? So once all the ticks are received, now I've used again a blue tick over here, but these can be of any color, right? So once this transaction is verified, a verified transaction can involve any of the things: cryptocurrency, contracts, records, any other information, right? Say, for example, we are talking about cryptocurrency. It has no intrinsic value in, and it is not redeemable in the form of commodities such as gold, has no physical form. It is basically not determined by any banks, right? So if the all ticks are received, then what happens? A new block is added to this particular chain, and the message is received that the transaction is successful on the mobile phone or whatever device you are using. So new block is added into the existing chain. Now this is how it works. Have a look over this slide. Right? So each time a transaction is requested and verified, a new block gets added to the chain. And now this is why we are referring to this as a blockchain. So blocks are getting added and chain is being increased. I hope you have understood the structure now. And if you have understood, I would be good enough to move ahead to take you through the next half of the lecture. Shall I move ahead?
Yes, sir.
Great. So how does or what does a block look like? Yes, now this is what a block looks like. I hope everybody is able to see this. This is what a block would look like. If you are able to see this particular diagram, what you see over here is, you see that these are some of the blocks: 98, 99, 100, 101, and all are having a verified tick onto them, given onto them, right? You can see them, right? Is it okay? Now, simplified block structure would talk about this kind of a scenario, that is the proof of work or the hash code, right? So what it has is timestamp, previous block, nonce, and version info, right? All these are the proof of work, including the Merkle tree hash, and then the transaction ID list, right? So each block contains all the transaction ID lists. Now this is why these blocks are important. So four key concepts of blockchain are what? The very first one is distributed ledger. The second one is cryptography. The third one, most important, is consensus. And the last one is smart contracts. Now, very important, very interesting. We have heard about these things. We know that these things exist in the market, but still we are not able to utilize them to the fullest, right? So these are the basic concept and ideas that we use as far as the blockchain technology is concerned, right? So I hope you have followed up till here, and I would move ahead to the next part. So blockchain architecture, basically this is a revolutionary technology which is talking about something like protocol, TCP, IP, HTTP, cloud computation, big data, IoT, fintech. So we can link it with any, right? Milan Swan talked about blockchain blueprint for new economy in January 2015, where he introduced blockchain 1.0, where Bitcoin and programmable memory was there. Then blockchain 2.0, where Ethereum and smart contracts came into picture. Blockchain 3.0, non-financial uses. Now, see, if you see these things, the concept is basically talking about implementation of new areas, or discussing new areas, and using this blockchain architecture to fields which were never thought about, right? I'll show you how interesting and how good it can be, right? So decentralized system, I hope everybody has understood now that the blockchain is following this particular structure. No federal or central authority is there. Public ledger means the ledger which holds all the transactions in the blockchain is open and completely accessible to all, and anybody in the public can see to it, right? Verification of every individual transaction is done by the existing people inside the chain. Now this is how things move, right? Low or no transaction fees. Actually, there is no transaction fees, right? Until unless I talk about something which is very extraordinarily done in blockchain, there is no transaction fee involved in this, right? So the key business benefits, again, I repeat: time saving, cost saving, tighter security, enhanced privacy, improved auditability, and increased operational efficiency, right? So how do you build trust with blockchain? Because this is a distributed structure, sustainable structure, a secure network, private network, indelible, transparent, auditable, consensus based, transactional, orchestrated, and flexible. Now just have a look if I have missed some word which in my dictionary which was talking about making a perfect transparent system for a common man, right? So this type of a structure which is based on blockchain is basically something which is talking about all these terms. Now who won't want this? But we are still afraid, right? Because we are not aware about the strength of the technology. So why it is called blockchain? Now this is how it looks like, right? So previous block hash. Now this is very interesting. Previous block hash. Now this hash is copied into the next. This hash is copied into the next. So it is very difficult for me to change the previous hash code. I hope you've understood now, right? So there is no technology right now which can change all the codes in all the blocks that are connected in the chain. That is very, very difficult, not possible at all, right? So which is not possible, then it becomes very difficult for anybody to manipulate any entries, right? So blockchain users, regulators, blockchain developers, network operators, these are some of the jobs also that you will see by these names. Traditional processing platforms, data sources, certificate authority, right? So all these are the different players which would which participate in blockchain. And this was one of the most interesting articles that was published by the New York Times magazine, Beyond the Bitcoin Bubble, right? So Stephen Johnson was the author of this, and he was talking about why blockchain is something which is beyond Bitcoin, and it is not a bubble technology, right? It will stay here, and it is to stay here, right? So Stephen Johnson basically talked that if there is one thing that we've learned from the recent history of the internet, right, is that it's seemingly a static decision about software architecture. They can unleash profound global forces once the technology moves into wider circulation. Now, say for example, I tell you today that I want to develop a new internet. I want to develop a new internet. How many, somebody will say this person is mad. He is not knowing. There can be only one network of networks, which is called as internet, right? But I say I want to build another network of networks. I want to build a new internet. Do I have the technology? Do I have the structure? Will I be able to do it? So these are some of the answers which blockchain technology can definitely give it to you, right? So what does a public decentralized ledger looks like? I'm just showing you that: transaction ID or hash code, date and time, sender, who sent it, asset, that is description, asset transferred, and who got it, right? This is decentralized public ledger. Private ledger is something different, which is all this information only shared with between sender and receiver. Now that is private ledger, right? The structure of modern database, how it looks like. Now, if you already have this in your universities, in your college, the director, vice chancellor, principal is the central authority, is the central database basically, right? He controls everything. So the institution managing control central database, users access to this, parties access to this, everybody wants an access to this, right? Because the information is available here. Now, if it was distributed to everybody, right, in the chain, this load would have been reduced. Now you must have seen that you appear or you want to apply for some job. The last date of that particular application or job online is a particular time period has been given. And on the final date, the server normally crashes just because it has received so many entries, right? It has received so many entries over that where the things are moving around, and what you have seen is that it crashes ultimately, right? Because the entries have increased. So what can go wrong in this case? What can go wrong in this case? Data can be changed or hacked. These are our apprehensions, right? Data can be deleted. institution can prevent access, right? Institutions can put conditions on access. Institutions can use data in unauthorized manner. These are some of the apprehensions, right? And everybody has it once the data comes into picture or once our money comes into picture, right? So whether data can be hacked or not, institution is very afraid. Can be deleted, yes, through firewalls, etc., right? Anything can happen. Also, students not given access to their metrics, ownership, intellectual property. Institution can verify, change, or charge for verification. Everybody does it. Every institution is doing it, right? If it is digital data, then this charge also fades away, and a handsome amount is also lost by the institute, right? So see, we are talking about something which is not good for generation of wealth in small cases, but it is very good for generation of wealth to others also, right? Institutions also gain out of this. A lot of burden is lost. You need not keep a person specifically for verification. You have already saved money, but nobody is thinking on these patterns, right? Sharing data with third parties, profiling of students, right? So yes, these things can definitely be limited if I have removed the central authority and I've implemented everything using this concept called as blockchain. So each user stores a complete copy of database. Each user has to approve each entry, and the version with most copies is the true version that is available. Now, I'll show you after this class how our one of the leading agencies, CBSE, has used this concept, right? The social value proposition in this case. Now, this is an interesting concept, social value proposition, right? So I think there was some problem. No, nevertheless, the social value proposition, self-sovereignty and identity, trust issues, transparency and provenance. I've already given you all these things. Immutability, disintermediation, right? How blockchain is starting to impact the education. Now, this is one of the coolest examples that you can see around you, right? Have a look over this. Issuer, certificate, holding a hash algorithm with certain binary data, which is the key or private key. And using this particular private key, the certificate is digitally signed with a tick, again with a tick. Hash of the certificate stored on blockchain. Hash code of this is stored. So if you have the hash code, you will be able to see that this particular certificate was issued to this and recipient receives this. I'll show you practically now where the things have been done by the government, right? I hope everybody knows the agency CBSE, right? Everybody knows that?
Yes, sir.
Great. So have you, someone close to you or someone known to you has appeared in 10th or 12th exam this time?
Yes, sir.
Yes, great. So this is how this time the CBSE has issued the certificate. I hope you can see this. Are you able to see this?
Yes, sir.
So see, DigiLocker verified, digitally signed by controller. There is no signature again, I repeat. This is the hash code that is available. If you have this, you scan this and the information is received. Not the marks, but the information, yes, this certificate is true. Now do you understand what I was trying to say?
Yes, sir.
Great. So now if this is stored on a chain, there is no fee required to be given to, I'll just hide this first, right? There is no fee required to be given to any agency to verify that this certificate is a true copy or not, right? Because this is already digitally signed and this is something that I actually wanted, right? Same thing can be done with the degree that we use or distribute in our college, right? So what can be done? The receipt, the content, and lastly the presentation, right? So the receipt is basically the one that we are referring to, which is digitally signed. I hope you have understood. Is it okay?
Yes, sir.
I hope there is no problem in this.
Kindly explain. Excuse me, sir. Please
Yes,
explain once again. There was some network issue at my end.
Okay,
Kindly
okay.
explain.
Okay,
So
okay.
sorry.
Ma'am, what I was talking about is how to issue, how this degree is issued, or how blockchain can help you remove different problems in issuing the degree. If you see over here, what we have is we have a signed one-way hash code, which is called as the receipt. The content is in the second layer, and the third layer is the presentation, outer loop, right? And you have public and private keys attached to this. Now, this is being issued by European Union. Every individual who is basically linked with this particular part gets a degree of this fashion based on blockchain, right? So automate and grow your certification or training program. If you are on to this, you are definitely linked with the leading universities around us. And if you see, European Union has all these universities linked in blockchain, and any certificate issued by them is given as a copy to everybody, and the student's record is always maintained there, right? I hope you followed this. Right, so this was a pilot project. I'm just showing you that the pilot project verifies the academic credentials on the Bitcoin and blockchain, and then this particular project is helping basically the students as well as the universities to maintain the record and see how their students move around or how the admissions are taking place, right? So blockchain is here now at EU national state level. I've already given the example. There are different pilot projects being run by different institutes to make sure that they are issuing these kind of degrees. You see this verify code over here. The signatures are already obviously on the structure, but you have a tick. Here it is, verified. If this tick is there, then that's great, right? So you need not pay anything else other than this thing, right? I hope you have understood this. Any problem still here? Now, how good it would have been, you can, I'll tell you one more thing. You can go to the Central Board of Secondary Education, CBSE, if you have done your degree, if you have done your 10th and 12th, go to that website and you can create your own DigiLocker onto that. I don't know how many of you have done it. Have you seen that?
Yes, sir.
So you can create your own DigiLocker and place your all the certificates over there, which will be verified and will be stored always there. Now, this is again a concept of blockchain coming into picture, right? I hope you have understood. There's no problem in this. So I move ahead. How might blockchain disrupt the education part? Where to apply the blockchain? Or these are some of the aspects. Issues and recognition of credentials, management of IPR, payments and smart contracts, several self-sovereign identity management, right? So these are some of the aspects. I'll quickly go through them because these are related with our aspect, but different universities are talking about this, how governance can be used, architecture and use cases, right? This is one of the examples, EduCTX. You can visit this website. This is talking about the governance issue. The online encyclopedias are available where different magazines are related, and whatever they publish, their reports are also verified. Or fake reports. You've been hearing this word a lot, right? I hope you're following what I'm trying to say. Fake news.
Yes, sir.
So how can you remove that? So make a blockchain of all the news channels who are providing news, and each news channel verifies, yes, this is true. How good it would be, right? Isn't it? I don't know. Is it or isn't it?
Yes.
It will be a good way, sir.
But how to centralize the data?
How to centralize the data? Now you have to make a consortium, ma'am, in that case. So you have to make a consortium of all the news channels. They should agree on this. If they agree, then yes, you are able to do it.
But it is difficult to, bring them to single consortium.
Yes. That is the case, ma'am. That is why everybody is running away from this, because they have to verify. They have to stay on that. Now, if you see, most news channels say that yes, this might have been published, or they even remove it. They don't even stick to their word. Now, but if there is some credentials, if there is something that is available in the market, and they have claimed these things, like you see, Wired, the New York Times, Forbes, Huffington, Bing Boeing, right? All these are basically names, branded names, right? So they have formed a consortium. And whatever news they publish, they verify it. They digitally verify it. So it is their scenario, right? Payment and smart contracts. Now this is being done by different agencies. One of the things was CrowdSale that we were using. So CrowdSale means you have been using it through Facebook also, right? People are selling their products in a big bunch. They have a complete chain of people around them, right? I hope you have seen that. But it is still centralized. It is still centralized, controlled by some agency, right? We want what? We want a decentralized structure. So this is one of the things. CrowdSale ended by BitDegree. So these are some of the platforms. I'm just showing you all these things, right? Civic secure identity ecosystem. So crypto banks have come in. Civic IDs are generated, right? So they recognize you by that. So what is the dilemma? Openness. Everybody is afraid of this, right? So if everybody is afraid of it, then what happens? Then it becomes very difficult to implement the same thing, right? So what we have is we have open blockchain, closed blockchain, and danger and opportunity of hybrid chains. Either be in this or in this, right? Never be into this. If you are inside it, then there is a big problem, right? So this is something that we must be aware. So Sony is doing it, Wipro is doing it, IBM is doing it. You name any company, everybody is working on this, right? So I'll just run away from this particular slide and contextualizing blockchain with internet. This is the important part. Internet 1, Internet 2, Internet 3. I don't know how many of you have heard about this, but I'll tell you, Internet 1 is the open web, 2 is the social web, and 3 is the blockchain web. Now, this is what I was talking about. Internet 1 works on open protocols, it is on closed protocols, and this uses both. It provides choices, whether open or closed, whatever you want to use. Right? Is it okay? So if you see, open web is being worked by scientists, academics, corporates, initially scientists, but increasingly corporates now, or startups. Application involves one-way data. If you see here, application involves transaction with large number of people. Internet 1, the open web is decentralized. The social web is always centralized. No, we don't want this, right? Internet 3, blockchain based, decentralized. Have a look at the market, 0.5 trillion, right? Yes, fragmentation brings great risk, and this is what we have experienced. If this system fails, or this centralized system fails, then what happens? Then what happens? Even if we are right, we will not get the data, right? Is it okay?
Yeah.
Yes. So this is the biggest danger. If the central system fails, you've seen it in Russia. The central system failed. The entire country was divided into 13 countries, right? So a big risk. Scam report, etc., etc. But the point is, again, but the standards and regulations can hinder innovation when we are still discovering what the potential of the technology, right? So this is what we want to achieve, and a three-pronged approach to work on this is regulate the blockchain policy. Yes, everybody should work onto this. The second important part is standardize education ledgers to ensure what? To ensure a common format for exchange or storage of data. Third is stimulation of applications, where within a secure and standardized framework, right? So we have a Dutch blockchain coalition, we have a EU blockchain coalition. There are so many blockchain coalitions coming up. If we are going to achieve what the social value proposition of blockchains, we need definitely transparent and evolving ecosystem, not closed or centralized system, right? So direct all to take action towards open blockchain or decentralized verification or vendor independence, right? So I'll just move away from this. This is a interesting example to show you how IoT is linked with this. Now have a look. This is a fridge which is giving a message to this particular person moving on. I don't know how much time is still left. Ma'am, how much time is still left with me? Are you able to hear me, ma'am? Can you just tell me how much time is left?
So we'll have time till 12 o'clock.
Okay, great.
45 minutes left, sir.
Thank you very much. Thank you very much. Right. So now if you see over here, the fridge is asking this person or displaying a message, don't forget to buy milk. What is Internet of Things is the question, and this example is the one that I want to recreate and explain to all of you, right? Now if you see, there is a message coming out from the fridge, don't forget to buy the milk. And if the fridge can give me a message that don't forget to buy milk, the things that are very complicated, this is a very complex situation. How does this particular device comes to know that I'm moving out or I'm moving to the market and I have to go to buy milk, right? And I have to come with the milk. So how does my fridge do that? Now, there are different things and there are different scenarios that are in the picture. You are leaving home, sense the user. There is no milk in the fridge, sense the object. Use this information to make decision. It is a process. Inform user about the decision, communication. Now see how many things are related with each other, right? So we'll answer it one by one. You're leaving home. How does the fridge sense it? What type of sensor is required? Distinguish between parent and a child. Identify reason for leaving home. Identify other contexts. Even example is store hours. Say I'm moving at late nights, then what happens? There will be no store open. I will not be able to buy that, right? So this is the very first scenario. A lot of computation required, but still IoT comes into picture, right? There is no milk in the fridge. What happens? What type of sensor is required? Is milk needed or not? Or no milk or little milk? Then again, this is prediction. Then to communicate, use this information to take decision and then communicate. So where is the processor? What are the rules? Fixed rules versus dynamic rules, that is learning of the system. And lastly, inform or notify, right? So how do you do that? How, when, privacy, subtleness, information overflow. Now, if you see this particular problem and I have linked this with blockchain concept, right? Actually, what I'm doing is I'm relating IoT with blockchain using this. If I link all these things together, I will be able to do it very easily, right? So how do I do it? Internet of Things or IoT brings in physical object, controller, that is the brain, sensors, which are very, very important, and we are surrounded by them right now with us, right? Actuators, and lastly, networks, right? So internet is definitely there. I told you we can make our new internet also, right? But that will still take some time. If it is based on blockchain concept and decentralized structure, you can make a different internet also, right? So the Internet of Things ecosystem would talk about what? It would talk about an internet network. Again, this has to be changed, right? Gateway, data with IoT devices, data with analytical and storage devices, and data with the persons, right? And everyone sharing in a blockchain network, right? So this is how the related areas and terminology would come. We have embedded systems, we have sensor systems, we have cyber physical systems, We have real-time systems or pervasive and ambiguous computing systems like fog computing or edge computing, right? Machine-to-machine communications, Internet of everything. We have been talking about it, and this picture everybody knows, Skynet. I hope everybody remembers this movie, right? So the Skynet is the one who is dealing with these aspects of these areas, right? And what we are referring to here is again a very interesting aspect, that machine-to-machine communication. Is it possible? IoT enables it, and if these devices are linked in a chain, right? They are linked in a chain, then they work accordingly, right? So again, Internet of Things, this particular term was coined by this British entrepreneur Kevin Ashton, and he was in his MIT Auto ID labs where he first thought about this concept, and he referred to future global networks which will be specifically using the RFID or radio frequency identification structures for communicating with each other, right? So any example that comes to your mind when I talk about this term RFID? I'll just go to the chat box right now to see. Any example that comes to your mind for the RFID? Anyone who can answer this?
Like the drones, they use RFID.
Okay, okay.
Sir, in Western Europe, they are using it in livestock.
Okay, great.
I read it in smart agriculture.
Great. Right. I'll show you all those things like now. But where you are using? I just
Fast.
right. You're
On
using it.
national highways.
You're using it.
Yes, sir.
Everybody. Yes, everybody is using it. Now that is again an RFID identification, right? So you cross and the amount gets debited from your account. There is no physical contact. You don't have to stop, right? Again, this is one of the good use. But again, you are connected with a particular server or the internet. So that is why I'm calling it Internet of Things, right? Complete automation of data collection, etc., etc. And this term, when introduced by Kevin Ashton, he talked about or he wrote about this article in 2004 from MIT called as Internet O or Internet Zero, whatever you term it, right? Right. So if now you look Internet of Things and blockchain, connected devices per person, have a look over this 0.08 in 2003. We have improved to 1.84 in 2010. Almost 3.5 devices in 2015 per person I'm talking about, and 6.5, or you can make it 7 to 7.5 in 2021. So just have a look with the number of devices that are connected with each other. Now these devices are already connected with each other, but yet we are using this internet structure only, right? So if a distributed internet structure is utilized and things are maintained, now I'll give you some examples where these things are basically being used sporadically, right? So if you see, what you are doing here is, in these cases is, you are using some of the internet scenarios, but you are also communicating with one-to-one structure, P2P. Even if there is no internet, you are still able to perform certain activities, right? So there are these devices which have come into picture. Now, as some participants have already highlighted, I'm just giving you this particular chart where we were talking about pre-internet era, human-to-human interaction, fixed and mobile telephone structures were there, SMS was being used. We moved with smart networks, Internet of Content, where www came into picture for the very first time, right? Email, information, entertainment. Next, it was Internet of Services, where Web 2.0 was introduced, e-productivity, e-commerce sites, right? So we introduced smart contracts with IT platforms. Then what was added? Phones with smart applications. Just a second. Right. Similarly, we moved into next part where we had Internet of People, social media came into picture, and lastly, Internet of Things, and now Internet of Everything. right? I can write everything. So when I write everything, I'm talking about more than machine to machine communication, right? So these are some of the things that we have been talking about of lately, and Internet of Things and blockchain, how they have combined together. I'll give you a few examples now, and then we'll end this particular structure to open the session for some questioning, right? If you see, this is intelligent traffic light over here. There are forecasts to be 28 billion connected devices worldwide by 2021. It has already crossed this structure, right? IoT devices will overtake the mobile phones as the largest category. Yes, that is why we are talking about linking of IoT with blockchain, right? So remember this. The number of IoT devices in Western Europe is projected to quadruple, right? This will be driven by smart meters and connected cars, consumer devices, right? Similarly, other things. So if we talk about all these things, we are talking about devices, location, application, and service sectors, all related to each other, forming a complete network. Again, this is not a centralized. Again, why we are talking about blockchain? Because we want to move ahead. Again, I should write blockchain over here with decentralized network. Right. So decentralized network would talk about this. So I'll just give you a very simple example. If you see over here, I hope everybody recognizes this. What is this?
Analog watch,
That's great. And what is this?
digital.
That's great. So there is some difference in both these things, right? I hope everybody understands this. And now what is this?
Smartwatch.
Great. So you can relate this with Fitbit, etc., right? Or some bands that we use for our health monitoring structure, right?
Yes, sir.
Is it right, ma'am? Similarly, if you see this particular diagram over here,
Our traditional switch and the
and now these days
modern device.
everybody wants to have a control with the fan switches, etc., using the mobile app, right? Is it right?
Yes, sir.
And normal glasses, and then you have Google glasses, and many more have come into picture, right? So see, we are augmenting different things, and we are connecting them together to make sure that we get the things. So now this is the complete structure.
Life becomes simpler
Yes,
and smarter.
this is a complete example of the IoT with the blockchain structure, smart city. As you see, we have a smart home, smart building, we have smart waste management structure, a smart society, smart care. We are talking smart with everything. Smart education, I just gave you the concept, right? Smart energy, where we are talking about green energy and development of wind power or solar energy, right? And we also have smart grids, supplying the energy to these from taking the energy, then distributing them, right? Smart mobility. Also smart cars. Now these devices are all laden with these RFID structures, right? And they are connected in network, and they are connected with internet, right? Now if a complete structure of this, say only this system makes its own network and tries and transmit the information to the other devices, and then similar city is connected with the other city, right? And they transfer the information mutually to each other. What is happening? What is the problem? What things are happening? Now this is where blockchain can come into picture, right? So there was an accident because of this reason. So everybody comes to know, and then they try and eradicate that, right? Rather than hiding it. Now, do you understand what I'm trying to say in this concept, right? I'll try and show you some examples, and we'll give you some time to discuss, right? So if you see this particular car over here, again, there are so many sensors and devices attached with it. If you see, we have radar sensors, we have GPS sensor, we have ultrasonic sensors, we have LiDAR, light detection and ranging, we have video cameras over here. Now, all these sensors and devices are doing what? They are helping us to monitor the status of the car, right? Plus, driverless. Driverless car. If it has to be driverless, it has to monitor its own structure. So there is a CPU also, central processing unit. Now, signal from the GPS is taken where it talks about the tachometers, altimeters, gyroscope, accurate positioning, where the vehicle is positioned, right? Ultrasonic sensors use the or are used to measure what? The proximity between two different things, right? Similarly, radar sensors monitoring the position of the car, video cameras monitoring the traffic light situation, LiDAR monitoring whether the car is moving in lane or the edge of the roads, right? Everything supplying the information to this CPU processing it and transmitting the information to this steering wheel, which is driving it, also at the same time giving it to the network that this car is moving at this speed to this location, right? If you see how many sensors, n number of sensors have been introduced here. Similarly, all these cars traveling on in a smart city on smart roads, generating their own frequency, all are connected again in chain, and everybody is transmitting to each other. Also, these people who are traveling are also connected together, right? So they are also transmitting and receiving the things, the information, and everybody is moving in the self-driving structure, right? So it is possible. This is a very interesting and new concept. Every industry wants it, and we call it Industry 4.0. Right, I can write it. Industry 4.0. Now they are looking into the concept of blockchain implementation with other things, right? So if you see, I'll just try and explain this to you. Innovation cell, efficiency improvement cell, you have an agility cell and a risk management cell. Again, they are connected, though they are connected with the central Ethernet. This is centralization, but this factory has individual blocks which is working on their own, doing some things and then sending it through this particular device to the other block, through this device to this block, through this device to this block, so that this particular risk management understands that we are trying to increase the production, whether the plant can hold it or not. So they'll go a green ahead, right? Everybody ticks it. Similarly, efficiency. If you want to improve the efficiency, every input is received, processed, and then all agree, and then only that particular action is done, right? So right now, this concept is very, very popular in leading industries, and everybody is looking forward for establishment of these kind of structures where the things can be taken into consideration. Everybody is a party to the decision taken inside this structure, right? So if we can do these kind of things, then it will be great help to the production as well as to the improvement and efficiency of the product, right? So new product and services can be introduced much faster, increasing the production quality and uptime, mitigating the unplanned downtime, and protecting from cyber threats also can be done, or worker productivity and safety issues can be increased by this, right? So this is one of the examples of Industry 4.0 being implemented through blockchain and IoT together, right? Similarly, what you have is you have smart and connected buildings over here. Now, if you see this example will tell you how easily and effectively lights can be saved, energy can be saved, basically, energy management, right? So at 5 a.m., though it is very early, the manager arrives for a global call. Very early, the sensor detects the car and exterior lights go on. Security system is granting the access, but because there is only manager, so wherever he is going, only those lights are on. So HVAC adjusts the airflow and temperature. 10 a.m. there is a meeting in the conference hall. The lights are on only when the people arrive and temperature is adjusted according to the number of people who arrive. Right. Similarly, 1 p.m. because sun is at its peak, the light from the sun is taken inside the building and then lights are dim. Right. So daylight harvesting. Similarly, 6 p.m. everybody is left the building, so lights are off, air conditioning is off. Only where work is happening, those places are on. Right. Overnight, when there is nobody, HVAC lights, all the security is set back, and everything is monitored on its own. Right. So this is basically a smart building. Now, if these smart buildings are connected together in different networks, right? And they are controlled by their own individual structures, then yes, we have tried to implement the blockchain structure. Somebody was talking about this, right? So in Europe, they are using it, and that is why I've just mentioned this, the connected cow, they call this project, right? So we have a necklace around the cow, which is again in Fitbit style, as I showed you, and it is checking around the cow's movement and feeding habits, right? Similarly, we have a pedometer, which is over here, right? It is basically checking or depending for the ostrich period when the farmers need to be alert for the best time of insemination, right? And then the acid monitoring meter is also interfaced with this particular cow, inserted inside the rumen of the cow, right? To make sure that the acidity levels and digestive problems are identified. Similarly, there are other sensors which are measuring the quality of the milk and signs of mastitis. There is a problem in this, right? And then tail movements, whether the cow is ready to deliver with the labor contractions, etc. So all this information is maintained by these sensors. They are connected by the IoT structure, and in turn, it is connected with the chain network also, giving a smart idea that yes, this particular feature is perfectly fine and in this position right now. Same thing can be done with all the other aspects, right? So I'll talk about this John Perry Barlow Internet Pioneer talk. You can go onto this platform and look around with Electronic Frontier Foundation, where John Perry wrote his final words. Blockchain might be the last chance to save the open web. This is what he referred to, right? So if we fail to do that, then there will be no open web. There will be all controlled web, like we are using it right now, right? So I would just like to open the session for the discussion among the participants. I don't know how to.
Sir, I have a question. Kindly explain immutability. You have explained while explaining the advantages of blockchain.
Ma'am, just a second. I'll just switch over. Actually, this is a new interface available right now. I'm unable to see the things. So I just open. I'll just stop sharing. Right. Okay. Okay. Now I get this. Right. I hope there is no problem if I stop sharing right now.
No, sir.
Right. So can you repeat the question again, ma'am? I was just looking forward for that. Can you just repeat the question again, ma'am?
Sir, immutability.
Immutability. Right. 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 So immutability, ma'am, is that you cannot actually alter any records. I showed you that slide also, where you could see there was a web type structure, right? So immutable means that you cannot alter anything. It is linked and weaved together. So if you say take an example of a sweater. So if you undo a thread, then the complete sweater comes out, right? I hope you have done that. Right, ma'am? Are you able to hear me?
Yes, sir.
Right. So immutable is very similar to that only. The immutability refers to that you cannot alter the things or you can change the things in any case. And that is why this particular scenario or the concept that we are talking about is referred to as immutable in nature, right? So you cannot replicate the things in any fashion, right? Or basically what I should say, you cannot, there is no, it is not susceptible to any kind of a change, right? So that is why this is immutable in nature, right? In any case, you can say it cannot be changed, right? In simple terms. So if I say something cannot be changed, then it remains there only. And this is what we want. So if a record has been written and it cannot be changed, then what happens?
It's more secure.
Yes, it is more secure. You're right. And it is more transparent also because it will not be changing at all. You've just seen it. And even if after 100 years you see it, it will remain the same, right?
Yes, sir.
I hope you got it, ma'am.
Yes, sir. Thank you.
Right. Thank you very much. Anything else?
Hello, sir.
Yes, ma'am, please.
So if some data which is stored in the blockchain is no longer required, like it does not hold relevance, then if it has to be deleted, then again it will require the permission of all the stakeholders there. Or is it that it cannot be ever deleted by like all the stakeholders together?
No. I just didn't understand the question. There was a little disturbance at the background. Can you just repeat it again, ma'am?
Okay, sir, I just wanted to know that like if some data does not remain relevant and it does not need to be stored, like it has to be removed from the system. So
Mhm.
like for example, in our personal PCs, we can just delete it. So
Right.
is it possible in a blockchain type of system?
Not at all, ma'am. If Bitcoin has been created, it will never be destroyed, right? This is the main part. So see, until unless the data is required, then only it is created. If it is not required, it will not be verified by everybody, and it will not be. It will not. If it is not verified, it is not created, right? So if it has been created, then definitely the requirement is there, and it can be utilized.
Okay, thank you, sir.
Right.
So in that case, then the systems will require a huge memory space.
The system should do what, ma'am?
It will require huge memory, right, for the storing all.
Actually, again, yes, you can say that the memory requirements are higher in this case, but the point is that we are just maintaining the ledger, ma'am. We are not maintaining the complete file with us. It is just the ledger record. Do you get this now?
Yes, sir.
So you can create n number of entries in an Excel or in a ledger file without even increasing the memory of that.
Okay, sir.
Because this is just an entry.
Okay, thank you, sir.
Right, ma'am, right. Anything else?
Sir, I have a question.
Yes,
I
ma'am.
actually have two questions. First, I have read a paper that told us about Merkle trees and blockchain.
Okay.
So, what is that, Merkle trees?
Merkle trees.
And second, IoT is also IoT is very resource constrained. So when we maintain ledger, that will take some of our let's say power or some other resources. So so this is a research area that needs to be worked on. What can be a solution of to that?
Madam, the first question that you talked about, basically it is a fundamental part of blockchain technology, the Merkle tree, right? So if you read that particular algorithm, it talks about the Merkle root where we have different hash codes being developed as hash 01, hash 02, right? So that is basically mathematical data structure, which consists of hashes. I hope I told you about the hash code.
Yes, sir. Yes, sir. Alright.
So
So
that
basically,
was,
hash in form of tree.
yes, ma'am, hash in form of a tree.
Okay. Okay, sir.
And this is basically using that Merkle tree mathematical data basically to control the structure, right? So that is why this is called as a Merkle tree. And the second question, ma'am, I just didn't understand what you said. Can you just repeat it again? The IoT part, you were talking about something.
If we use blockchain in IoT, then these ledgers that are maintained, it will be as IoT is very resource constrained.
Right.
So how do we keep ledgers then?
See, ledgers are the basic aspect. See, again, ledger, you don't confuse it with anything. It is just the hash code.
Okay.
So if you are creating a block, or if you are linking any device and it is creating a block, then hash code is generated, right? So those hash codes are definitely saved somewhere.
Okay.
Right. So that is not a problem, because you have already answered your question had the answer itself. The Merkle tree is the concept that you normally use for this hash code encoding.
Okay, sir. Yeah.
Right. So
I was not able to associate both of them. Thank you, sir.
okay, no problem, sir. Right. Anything else?
So what can be the problems between a hybrid type of network where like you have some chains which are private and some which are public?
See, madam, yes, this is a scenario where you can also have a private blockchain inside a public blockchain, and that particular concept is called as hyperledger, right? So in that case, you are still connected in the blockchain network, but say for example, I want to propose a deal to one of my friends at a certain rate, right? And I don't want to disclose that rate to everybody because I'm already dealing with other people on a different rate. So I have the option to propose a private blockchain with that particular person. The deal disclosure will not be made, but yes, whatever transaction, it will show that some transaction has happened between A and B, right? But that will be very private. The deal will not be disclosed. But yes, the other people will come to know, yes, there is a transaction between these two parties.
Okay, sir. Thank you.
Right. So that is basically being developed as Hyperledger concept. And if you want more discussion or more information on this, you can visit the Linux Foundation. The Linux Foundation is working on this Hyperledger concept. So they have introduced a lot of things.
Thank you, sir.
Right. Right. So anything else? Any other questions?
I request all the participants, if you have any questions, you may please ask. I don't think so. So now, if anybody.
Right, ma'am. Right. In that case, that's it from my side, ma'am.
Okay. Thank you so much, sir, for sharing your valuable knowledge with us, and you take the query of the participants. So thank you, and you have solved their doubts as well. So thank you so much, sir, for sparing your precious time with us. We are really overwhelmed by your session, and thank you so much for your presence, sir.
Thank you very much again for inviting me, ma'am, and thanks for the wonderful audience that you have. They were listening and trying to answer the things in beautiful fashion. So thank you very much for paying attention to what I had to say. And I hope that this particular thing you are able to implement. See, there is a lot of scope right now for different research papers to be written, with different research to be done in this particular field. And I hope that you will be doing it, or you'll be trying to implement the concept in your research. See, blockchain can be implemented in various issues. I recently used it in wireless sensor network. right? So you all can do it. The point is that you need to understand how to do it. So I was just trying to introduce the article to you. I hope you followed it, and thank you very much, ma'am. Thank you very much.
Thank you so much. Sir. Thank you. Thank you.
Thank you. Have a nice day.
Thank you. Same. Dear participants, now we'll have a break of 5 to 10 minutes. Then we will have our next session. Thank you. I request all the participants to please fill their attendance as the link is there on the chat box. Rupesh sir, am I audible to you?
Hello.
Yes, sir.
Yes.
Rupesh, shall we start the session?
Yes. Yes.
Good afternoon to all the participants. Today, we have with us Dr. Rupesh Kumar Devang. Dr. Rupesh has done his PhD from MNIT Allahabad, his MTech from RGPV, postgraduate diploma in cyber law from NLIU, and his B from RGPV. Sir has published more than 25 research papers in reputed journals and national and international conferences. His area of interest in ML, data mining, big data, data science, cyber and information security. Thank you so much, Professor Devang, for accepting our invitation and coming over here. I welcome you on behalf of SoIT, and I request you to please start the session.
Okay, just a minute.
So you are the co-host and you have the rights to share your screen.
Yes, the screen is visible.
Yes, sir.
Yes, sir.
The screen is visible.
Yes, sir. Yes, sir. It is visible.
Okay. So good morning, and now is good afternoon. From 12 is go. Okay. So today, as we have right now, I think 4 or 5 day of this FDP, and many of expert talks already means talk about your IoT. Now, in this talk, actually, we will see the new era. Okay. So right now, without machine learning, we are not able to survive in current scenario. Okay. And as you know that the era of IoT is also be there. So due to this combination of these two things, new era have just introduced. Uh, we can say in just 1 year, that is internet of behavior. Okay. And which is based on the machine learning and over the IoT. So we will see the in this today talk, we will see the what is the basically internet of behaviors and how this machine learning is helping for using this new technology. And this is an emerging research area even. Okay. So content of today presentation IOB, internet of behaviors, IoT and IOB. One hype cycle is always used for seeing the whatever the new technology is lying in this current year and forthcoming years. So it is by the Gartner. We will see the some application you have already covered, but in as perspective of machine learning, we will see what are the applications are available. And next we will see the machine learning in IoT, and we will see one or two case studies according to based on the means how we are gathering the IoT data and how ML is basically applying. Okay. So IOB, I think many of you may be aware or not aware. So, but basically is basically the behavior analysis. Okay, internet of behaviors. So as you know that we are totally connected right now with the internet. Okay, means our devices like our TV right now connected with the internet, our geysers, our air conditioners, and our even our daily activities even connected with the internet. Like smartwatches means we are using, everyone is using, even now from the, we can say by the age groups, we can divide into the age groups. So from the child even is using the smartwatch, and even the older person is using a smartwatch because of monitoring daily activities, and it is playing the very important role, and it is also connected with the internet. Okay, and this internet basically connected with our mobile phones. So means in this in current scenario, the internet of behavior is very important, and everyone is catching our data, like smart devices, whatever, means your searching behavior also be catching by the your smartphone, your smart devices like your smartwatch is catching your pattern of heartbeat and your pulse rate, and means how much you are walking and whatever the daily routines activities performing by you. And daily activities means, suppose that we many of you are using the right now for listening the song that you can say connected with the IoT, and you know that the preference already, whatever you like for listening the songs or watching the TVs about any shows, any movies, they already know the your behaviors, means whatever you like and dislike it. So internet of behavior means, suppose that we can tell you one story here, like somebody has come to you and saying that we have saying that that's your current mobile phone is not able to operate. Okay, so you will say that why this is not will be operate. So you can again say that because right now new technology is coming like 5G. Okay, and 6G is basically introduced. We have seen in newspaper earlier 2 days newspaper. The 6G is working started in India even. So 5G, we are talking about the 5G. So that means you need to change your mobile phone, because if you are not changing your mobile phone, so you cannot use the 5G. Okay, so that means you can see that how technology is basically changing, means with that respect to time, the technology is basically changing very fast. Okay, so means you need to aware whatever the connectivity means, whatever the new things are available, and you need to connect with these available things, otherwise you will be suffering of that. Okay, due to the lack of connectivity. Okay, like in 2G and 3G network, right now we have the 4G networks. Okay, so if somebody is maybe so suppose that right now using 3G network, so it may be suffering from the many activities, because right now many apps, or even the new 4.0 is coming in current scenario. So many apps and many technology is basically running on the new technology only. So internet of behavior is basically means identify the user behaviors. Okay, means whatever the users are connected. Suppose that you having a smartphone. Okay, and this is connected by the smartwatch, and they are counting the your daily routines. Means whatever you are eating, even that reminder you the means drink of the water. Okay, means whatever the calories you are eating it. Okay, and whatever the you are doing the how much activities even. Okay, there are many apps is basically are supporting these activities. So that activity is basically counting, and that also be counting means in particular 24 hours, the how much you are sleeping, how much you are eating, and how much you are taking the means stress even. Means stress means whenever the stress is going, as you know that the stress is going to high level, so it means your pulse rate may be increase, or your the heart rate also be increase. Okay, and you may be not aware with means lacking of something, and sleeping disorder may be increased. So it is also calculating the stress. So all the things is basically available, connected, and this data basically is stored in the cloud, and this data is basically used for next, means how to resolve this complications that is occur previously. So how to resolve this complication in next day. So they will suggest you some important measures for this purpose. So internet of behavior are many sectors you can see in the example. Uses whatever you are using. Okay, so that uses data is very important in this current scenario. Behavior psychology means, as you know, the behavior psychology is depending upon the many things, not only one things. Okay, that depending upon the many things means how you are thinking about the particular present thinking, means whatever you are thinking in present scenario about anything you can see that, like in the purchasing behavior we can say currently. Okay, there are many behavior analysis like purchasing behaviors. So purchasing behaviors of going to shopping mall and doing the shopping, purchasing something. So that means what you need here present. Okay. So that means suppose that somebody is purchasing jeans and t-shirts. Okay, currently. So this is one behavior of that is stored. Okay. And next time you will go for shopping again. So it might be chances, that means that might be chances on the basis of the your previous data that will suggest you the new things. We have same things we have seen in the various previous recommendation systems also. Okay, so that means currently the using the IoT we have enabled the machine learning here. Okay, so behavior psychology is one of them. Behavior analysis means analysis of posting of particular reviews, and behavior analysis of particular shopping activity, and each activity, whatever you are posting on Twitter's, how you are means look like, or maybe likes the different post, whatever your means current thinking about the particular suppose that any political issues about any issues, so that is means against or whatever, so it is also be recording here. And these three things is basically is connected with the IoT devices. So as you know that connecting with the IoT devices, so all these are the storing the data here. And these devices basically store the data. We need to again use this data. That means we are here we can apply the machine learning techniques and generate the some knowledge basically, and this knowledge may be useful for doing the next activity, means solving the next activity users, means it might be used for the support to users, or means providing the users some services also. Okay, so this is the internet of behavior. I think that is clear. Now you can see that IoT and IOB is basically as is a complete one thing. Okay, so means in this pyramid you can see that IoT is basically means gathering the data first. First in IoT, what we are doing it, how we can going up to the IOB. So that means first we are gathering the data, and this data is very useful, like collecting the data, and that the data is daily activities. Okay, so we can say that like we can again consider one application here, like health monitoring of particular patients. Okay, so the health monitoring of a particular patient, that is means right now in hospital. Okay, so means whatever the pulse rate, how they are eating, how much they are eating. By the right now the cameras are, you know that the cameras is also catching the food, whatever you are eating, even the calorie they can suggest you what how many calories even in your particular food that you are containing. So that data is suppose that is catching, and this data, and again if suppose that any anomalies means any alteration will be generated, like the pulse rate is going on, heart rate is going up and down, or the BP is increasing, even the sugar monitoring. Okay, the automatic sugar monitoring is basically just even supported by the IoT. Okay, so I will give you one example of that. So that means all these things basically are catching here. Data is catching here, and then this data is going into the providing some information. That information means that is useful for the doctors, like hospital. Means on the basis of this information, doctor will decide it to be going means support to this medicine or change the medicine, or we need to use some other things, like, okay, means whatever the next treatment we can go. So this information is basically collected. Now this is the internet thing. Now on the basis of this information, now from this second part, the machine learning will be playing the role. Machine learning will see that this pattern is basically means heart rate is up down, BP is up down, and whatever, and the sugar level is up down. So machine learning parameters checking that means whenever that is increasing these parameters, the machine learning will predict the next outcome automatically. That is means already trained. Our model is already trained with the using the previous values of other patients. So that will be predict the next outcome. How much that is accurate, that is depending on, but we can say that this is thing is happening, so that might be happening in future. So that is called the knowledge. And this knowledge, but that basically this knowledge is basically is providing the wisdom finally. Okay, means on the basis of this knowledge, you can say that yes, we can apply this thing, so we can solve this problem. So this is the pyramid of connecting with the IoT and IoB. Integrants of IoB, you can see that that is again connected with the data analytics, because it is also be merging with the data science, and you also we see that. So IoB is connecting with the data and analytics, user experience, whatever the user experience, we can also be connecting it. And finally, platform and applications. So these are the integrants of IoB. Means all the things are basically integrants in the IoB here. Okay. Advantages of IoB, there are many advantages. Some few are listed here. So you can see the first is analyze the customer buying habit across the platform. I told you this thing. And previously, we have seen that buying pattern analysis by the business intelligence is basically there. Means we have the scenario, we have the data mining even, and we have seen that there are means whatever the next buying pattern of customers is basically automatically catch. But right now, IoT devices, if you are searching something, suppose that I give you one example again here. If you are seeing that you want to suppose that purchase one microwave, okay, and right now winter is going, so instance of microwave, we can say that like heater you want to purchase, okay. So automatically, whenever you are scroll down your Facebook, so automatically you can see that some ads advertisements are coming, means giving the some discount of the whatever the heaters. So what is this? This is the means analyze, means there are co-op, means collaboration with the searching behavior of Google and Facebook. So automatically they are providing you the services, whatever the next you want to purchase it. So that means analyzing the user search, even analyzing the customer behavior. Okay, buying habits means somebody is buying. Suppose that somebody is buying the winters, as you know that somebody is want to buy the every in winters is new sweatshirts and new sweaters, even jackets. So this pattern is already stored. So when again, suppose that new winter is coming next time, so automatically you will see that some discount is available on the sweatshirts, sweaters. Okay. So this is one thing. Next is study the previous unoptable data about how customer interact with the device and end products. So previous unoptable data means you can see that that is not easily we can obtain. So how we can say that this previous unoptable data we can use for providing the providing the services to users here. Okay, so unoptimal data maybe suppose that you can say that like the buying pattern of user is not available. Okay, but we can interact the users by giving some choice. Okay, and these choices basically, these choice in this basically the devices and products basically devising and products is these choices providing is the new study in which you can user can be select yes you want to buy or not. So as somebody may be thinking in this point, second point, that's 2 point is correlate, and somebody may be thinking some whatever the audience may be thinking that is IOB is business perspective. Yes, this is the actually is belongs to the business perspective. Even the IoT is belongs to the business perspective. Okay. Next is gain deeper insights into where a customer is in the buying journey. So as you know that the customer buying journey is basically is very long. Okay, like again I want to give example here, like a user is going somewhere, means somewhere for visiting some place, suppose like Shimla and Manali. So due to this visiting, so whatever the user like and dislike, automatically they are capturing the whatever the location, recent locations, and they will suggest you the near about market, and that is tie up with these markets also. So you can see that whatever the available things even. So that is gain the deeper insight. This is one example. There are many examples of gain deeper insight. Providing the real-time point of sale. This is one thing. Point of sale, real-time point of sale, notification targets advertisement. Okay. Real-time means whenever you are going to shopping markets and instance of location fetching, again, same thing is correlate here. And providing this, yes, you can purchase this thing.
Sir, you are not audible. Is there some network? I think there's some network issue maybe.
Ma'am, I think there is some network issue. We'll wait for 2 minutes.
Yeah, sure, ma'am, sure. Participants, there is some network issue. Please wait for 2 minutes.
In the meantime, attendance link has been posted.
Rupesh sir, am I audible to you?
Network problem on his side. So he's trying. In the meantime, participants, please fill the attendance for the session 2.
Our participant sir is joining in a minute. I just have a talk with him. There's some network issue at his end. So he'll be coming in a few minutes.
Hello. Hello.
Yes, sir. Yes, sir.
Yes, please allow to share the screen.
Yes, yes, yes. Yes, sir. I have made you the co-host.
Actually, this side is some proxy issue.
All
So
right.
again, it might be, if suppose disconnect, so please call me on phone, okay?
Okay, fine. Sir. So you are the co-host now. You can share the screen.
Yes, just a minute. Yes, the screen is visible.
Yes, sir. Yes, sir. It is visible.
Okay. So last slide is this Gartner, I think. I was in this slide last. Okay. So Internet of Behavior is new era in which actually some issues also be there, like the privacy is one issue, security, and security is comes, so privacy is one issue is coming. As you know that data is in Internet of Behavior means data is coming too fast, and we need to analyze some these data even very fast amount. So big data also be coming here. Means that is coming in streaming data. So whenever the streaming data is lying, so we need some big data computations even for real time analysis even. So this is the top technologies. And next you can see the 2016 we are talking about here, the Gartner hype cycle, and you can see these are the 2 to 5 years blue portions. My mouse pointer is, I think, is visible, and this is blue. Light blue is, you can see that is 2 to 5 years, and 2 to 5 years you can see that IoT is one of IoT services. You can see that IoT customer services, connected homes, and machine learning. This is light blue. Dark blue you can see here. The dark blue is basically IoT enabled ERPs, IoT platforms, IoT architectures, wide area of network IoT, and Internet of Things event stream processings. Okay, so right now, from what I want to tell here, that means from the 2016 we have Gartner is predict this thing, and now after 5 years, is to 2021, and next 5 years you can see that this is basically are going, and right now machine learning is top of the trends, even with the compare with Internet of Things. So that means Internet of Things and machine learning both are going in the top of the trends here. Okay, and you can see that this timeline, and this is the timeline. You can see that is innovation is triggered in which point, and this is the peak. Okay, and right now the peak is machine learning within a 5 year to 10 years, and IoT with. Okay, so expectation of peak is right now is whatever the expected in 2016 is right now is basically correctly predicted, we can say correctly expected. And you can see the IoT integration is going down here. Okay, so that means this hype cycle, and sometimes it might be this is one prediction, so it might be sometimes it's not maybe corrected, but it is predicting whatever the timeline of this. So this is the high peak is Internet of and machine learning is both is coming together here. And whatever the leverage machine learning application in IoT. So you can see that the different application like, and again, this is the same timeline as expectation is covered here.
So right now, this is innovation is triggered from the smart dust, and this is again you can see that hardware, smart discovery, and blockchain top of them. 5 to 10 years again, blockchain is going top, but IoT platform you can see that is 5 to 10 years is going top. My voice is coming or not? Yes, hello. Am I audible?
You're audible, sir.
Yes, sir.
Okay. I'm fine. So in this current scenario, you can see that machine learning is top here again, and which is combination of IoT in 10 years and 5 years is going to top. So different technology with related to machine learning like is going to top here. Okay. And you can see the total number of active devices connection worldwide in last few years from the 5 years, and for forthcoming years like next 5 years. So total number of 10 years, how many internet IoT devices we have connected. So in the globally, you can see. So that you can see in that is very less devices in IoT, 3.8. Okay, in billions we can say over the world. And from 2018 you can see that is increasing from just double here. You can see that is just double 7 point something 7.0, and right now in 2021 after 3 years that is again increasing to 3 times from 2015. So you can see that increase up to the 3 times. Now after 3 to 4 years that is increased just from the 12 to 24 or 22 around. Okay, so IoT devices is increasing continuously, means the scenario in which currently the active devices of connection of IoT is increasing. So we can say in next 5 years we have many devices. Right now, even the cars we have seen that is IoT enables. Even the smart washing machines and many whatever the appliances we have using is basically is connected with the IoT devices. Even they are collecting the things. Now, working of IoT is Internet of Behaviors. Working of IoT is basically based on the how data is collected, means where you are collecting the data and which sources you are collecting the data. So different data is collected from the different devices, from the smart apps, even like a smartwatch and smartphones. You are searching behavior, your buying behavior, your driving behaviors, even. Okay, means your listening behavior even is captured here. So how many devices you have connected? So that is data is connected and collected by the different device and is stored somewhere. Storage is very like in cloud, basically these data is stored. Next is when the data is collected finally. So what happens to the information gathered? So we have collected the data. Now we need to perform some computations here, analysis we can say. So once data is collected, we need to analysis and predict the something here. So this means what type of analysis basically we are using, means which type of data and with which type of prediction we need to perform here is basically here we are doing this thing. Means when information is gathered, means data is collected, what happens to information gathered means how behavior of particular user we want to see here. Next is using data from the variety of sources. So data from a variety of sources is basically talking about the combining data from many different sources, and finally we want to take some decisions. Okay, so combine the data from different sources and take to the decisions. We can take one example here for all these three processes. Like customers, as you know, many of you are using Facebook and Instagram. So that means if you are posting something on Facebook, okay, means suppose that if you posted some iPhone purchase, so that means that data is captured, means you have newly purchased the iPhone 13, and this behavior is purchase, means this behavior is purchase. This purchasing behavior is seen by your Facebook, because this photo is posted by you. So automatically, again, after a few times, you can see that some case covers and some gadgets discount available on your screen with related to iPhones. Okay, so this is the working of IOP. Means data is collected, happens to information. What happens to that information is gathered, means that information is gathered, then means providing new services, and there are different sources of data basically. Uses, applications, different use of IOB in various sectors. Like IOB in business is available. Like you can see that there are various online advertising companies available, and which is supporting various variety of businesses to customer. Okay, this is like IOB in business. Okay, like I already given this example, like Facebook, whatever things. Okay, next is IOB during the COVID pandemic uses. As we have seen that, like in COVID pandemic scenario, we have seen that many means public is basically use the precautions here. First thing is to use the precautions. Precaution means washing the hands, cleaning of your whatever the items you are purchasing by the groceries even. Okay, so even whatever the markets you are borrowing from the markets, like, so that is also be clean. So this thing is basically captured. Like, and same thing from we have seen like Zomato and Domino's and even the Swiggy is providing the one thing is here, one advertisement here. That means whatever the persons are coming, okay, for delivering the foods, delivery boy. So these are totally checked. That temperature is automatically checking, and that is continuously monitoring. Okay, so this is one thing with the IoT pandemic, means IOB during the COVID pandemic. Insurance industries, IOB for the insurance industries means, as you know that the driving vehicles are now IoT enabled, and means your speed, your tracking of it is also tracking your way of using your vehicles. Means if you want to let left turns, it might be not possible in India, but in some foreign countries is basically using it. So if you want to left turn and without left turn, you can do it by the means and without indicators. So it means dangerous how much time you are able to touch your 80 and 100 speeds in roads. So automatically the insurance industry know that the current car condition, even your and providing you the insurance and whatever the other things related. Okay, so these are the uses of various sectors. We have already seen this thing, types of Internet of Things, and already you know that we have mainly this is the security and privacy, you already know that smart cities and home applications of IoT, device and variable connectings, already you know that blockchains is very important part. And now blockchain is even using the securing the data for transferring from one into another, and that is might be not altered. So this is one thing. Industrial automations is another one. Okay, so types of internet thing is not talking too much here because that is already taught. So this is one security privacy. You can see that the data is you can see here the data is transit in many sources like things, mobile gateway, cloud, and enterprise. And same thing in IoT, we have seen that data is stored in many sources even, and they are collecting the data. So that you need to assure that means industry or whatever the data storage, assure that that is violation of privacy is not be done, or how much violation is down. So this is one research is going continuously for this purpose. Okay, so there are 3 points written here, like highly security centric life and death applications. Okay, intermediate security users that include the smart homes, means in a smart home in intermediate security uses, alarming systems and whatever the other things. Okay, and lower one thing, this is the 3 levels. So lower security casual users in games. So this is one thing in games, that is lower securities, and in a smart home that is a medium securities, and whatever the highly securities means that is belonging your life. This is the highly security centric. So this is 3 levels actually. Okay. So smart homes, you know that these are the one example. It means everything is connected. A smart city and smart homes. So home area network, ZigBee, Wi-Fi smart homes that is connected, wide area network, smart cities, and field area network, smart end-to-end. So it means that IoT is lying between these 3 all pillars. Okay, home area, wide area, and field area. All the things is basically right now is whatever the device is connecting with the IoT. So that is a one main pillar here. So what are the different services and different partners available, like Amazon Echoes? We have seen Alexa. Right now, Alexa in every home, because that is very easy to purchase and cost is very less. So and now plugs, smart plugs are available. You can connect some devices also, even that from the Alexa. Okay, Apple TV, Arduino. There are many services. Okay. Next, you can see that what the roles of the IoT smart living in industrial scenario. You can even visit the Indian government sites. Okay, government of India sites like industries, innovation site, and many other government smart governance Indian sites here. So you can see that in India currently the smart governance in Bhopal. Okay, so it's even in Bhopal, Indore is using that smart governance. Bhopal Municipal Corporation partnered with the SAP to automate public service offering. Other cities, even in smart building, smart health, smart transportation in India, all over the India, basically using it. Okay, so there's not even, there are many cities that is providing it. The smart management of things, of particular recent things. Okay, so this is over the India. What are the devices we have connected? Many devices like handsets, computers, handset computers we have connected. Health bracelet is connected, and chip on the sensors. Chip on the sensor is connected with the locations, song, other things. Handset is connected with the emails, bracelet, heart rate, locations capturing, AV glasses. You can see smart watches. So all the devices, variable devices connected with the persons here right now. Even means more than one device is using by the persons of IoTs. Blockchain is one of the recently is big technology which is providing the two-end supports of no one is deny. It's basically concept. So that basically you can see that the different partners available in India. This point, we are not talking about the blockchain here. Okay. So machine learning, we have seen that the machine learning we want to apply it on IoT. As a machine learning point, here I want to tell one thing here means what is the machine learning actually belongs to. So machine learning is basically is a program where you want to have some experience. Means suppose that I want to give an example. I'm not reading the whatever the written here definitions. You can see that one new object is coming in front of you. Okay, like you can say that any new object like new tablet. Okay, you don't know about this object, suppose that name of this object, and you can just relate them. Okay, once the tablet pager is first time come, once the mobile is first time come, you don't know about this object. So that is one display unit, one thing, one button is there, you can communicate it. So name is given to the telephone or mobile phone. Okay, same thing with the tablet. It is look like, but is portable, we can use it. So that is touch screen available. So that is tablet is name. So that means how you are giving the name actually, that is means your past experience. Okay, means your previous learning. From the previous learning, you can decide it, yes, this is the same thing. So it is categorized into this means a smartphone or tablet or more laptop. Okay. If you don't know about the category, so how you will do it? So that means if you don't know the categories previously, means you don't know about the previous learning. So you will use some mathematics for this purpose. Mathematics means some calculations of your mind. How the human mind basically doing. This is the general scenario I'm telling. So general scenario means human basically thinking about some relations, connecting with the similarities here. Okay, and saying that yes, this is the one pattern. It might be this pattern. So this is called the unsupervised. Previous one is supervised. You already know the class, and new object is coming, so you can categorize it. So this is previous one is supervised. If you don't know the class, but the object is coming, and you are not able to say that on the basis of class, you are not able to say that this is belongs to this category or this category. So how you will say that? You can use the similarity measures here. This is called the unsupervised. Okay. So there are two basically techniques, supervised and supervised, and reinforcement one of them. Autocorrelation is basically performing it. So here this is the basic of machine learning here. So learning means improving with the experience. And some tasks, example like smart homes. Okay, means improving with the experience. Improving, we need to improve it with some experience. So traditional machine learning is basically traditional programming. You can see that some accelerometer data is basically coming in, walk and run. Computer program, hard-coded instruction was there. And that is program is checking out, yes, walking and running. But machine learning accelerometer data is coming here. And that is data is many different people's. Means there are only not one people, there are many different persons data is coming. Some machine learning, whatever the supervisor and supervisor is using here and telling you the walk and run with whatever the even suggesting the basic terminology behind this, means basic rules behind this. Even learn the rules here, walk and run. Like human activity detection, task is human activity detection here. So a standard approach by the computer program That is the activity, suppose that. So handwritten program is like this one threshold value and then is given here. So that is sitting, that is one values in between. So that is standing. Okay. So this is the formula of equation for folding of the calculating the activities here. So this is the one standard approach. What about the machine learning? Machine learnings, we have given the some inputs, means this data and output. So that means machine learning is basically we have some models. Once models is built, so on the basis of model, that machine learning algorithm will predict it, sensor the data and activity automatically. So this is the IoT enables things here. So types of ML algorithms, there are many types, many types available right now. Even deep learning, example learning, neural network, regularizations, rule system, regressions are there. And there are some subcategories even there. Okay. So Bayesian learning, even decision tree and dimensional reduction. If there are many dimensions, very important part. So dimensional reduction is one part in which you want to reduce the dimension. Sometimes we need to extract the dimension and sometimes we need to reduce it. So I want to tell you one thing here, because there is very basic thing here. I think some researchers also be there, like PhD scholars also be there. So I want to tell one thing here, like in machine learning, whenever what the basic researchers and some basic students are doing here currently, they are using the old model as it is, whatever the available online, and applying into their own applications. But actually the model is basically built on the different applications. Okay. So if you are applying it on your applications, so it might be the accuracy is too much, not giving too much as accurate. So you need to build your model, means develop your model on your application, then test it. Okay. So one thing is dimension reduction, means there in one problem in machine learning, we want to increase the dimension one time. Dimension means attributes. Okay, we need to increase the attributes sometimes. Where suppose that in one problem like email spam detection. Okay, so there are few attributes available of emails. From the few email available attributes available, we cannot do the categorization of particular email is spam and not. So we need to extract the dimension here. Okay, but sometimes we need to reduce the dimension even. Suppose that like the gene expression data, and in gene expression data there are many dimensions. You can do the many things here with the gene expression data. So you need to reduce them on the basis of whatever you want to apply it. So that is dimension reduction is there are many very important. So as means which attribute is playing the role in your calculation is basically used. Okay, so that's why this dimensional reduction tell you the which attribute is playing the role here. Okay, for your problems in this category. Okay, so that is depending upon the different means whatever you want to do, what type of analysis you want to do. Okay, so ML algorithms, you can see that there are, you can see that some objects is presented here like banana, some cutting apples, some is happy apples are there, some banana is old here. Okay, and we want to, what here we want to do here means we need to classify, apply the classification here. Okay. Please mute it. So you can see that in this is the one data actually. This is one data. And now we are applying the regression here. How to estimate the price of the fruits. Regression is basically it's continuous value, you can apply it. So how to estimate the price of the fruit if freshness in days is given. Okay, means freshness of particular days is given here. So how you can estimate the price of the fruit. So you can estimate by the freshness very easily. Okay. So that you can plot the freshness of the food. This is the lowest freshness. This is next. This is next. This is next, and this is the topmost fresh in the fruits. Okay. So that you can say that this is the freshness is high. So this is price is also be high. So this from the how you can say that this from the regression analysis you can see that. Okay. So that means your device is automatically capturing this images. Okay, and on the basis of this image capturing, your device is applying the freshness of categorizing this into the on the basis of the freshness of foods in the days. So regression you can apply it and automatically categorize it, means price prediction. So what the how to estimate what are the training data is basically is labeled instances X and Y, and object to develop the relationship here means means relation with the price with the days with the price. Okay, so predicting Y for the given X, and discrete values of output will be given here. Finally, the price will be this one. So this one you can see that this is the price is this one, and this is the peak value here. Here the values is much more higher. Okay. Next is how to identify where a given fruit is fresh if freshness is not more than 50 days. That means there are two types of class. That is two class problem. Fresh fruit, fresh is not fresh. Fruit is fresh or not. So that days you already know that. So on the basis of days you need to classify them. So you have data set. You can draw some decision boundary here, and any classification algorithm you can apply it. And this is draw the decision boundary to categorize the two data completely. Okay. Now, next is clustering. How to put the fruits into baskets. How to put the fruits into two baskets. This is the actual data. And two basket means that is similar data you want to that clustering actually. So banana is not similar with the apple. Okay, so you cannot put them to two basket. There is actually you can see that the previous two problem, this problem is totally changed. In previous two problem, we are saying that freshness, okay, classification and regression. But here we are put down the fruits into two basket. So that put down the two fruits in the two basket that's similar. How much that look like a similar to each other. So bananas, that means two basket whenever coming. So it might be chances some unfresh fruit may be into the basket here due to the similarity. Okay, but here next you will apply the again clustering here, again the similarities here. So you can see this is a similar, this is similar, this is similar. So this will come to the one basket, and the rest of the happy one is going to the one basket same way. So again you can apply it. Okay. Next is you can see that smart homes respond to user with a smartphone. This is one category. So right now this is the scenario even in current scenario. So that is all the things is connected. One is need to be connected with the internet. One thing here. So user come up with the office after the office like 5 p.m. The person is enter into the room. So smartphone they having hold it, know that they are coming into their proper one destination. So whenever the smartphone they are holding it, so automatically whenever they are enter into the room, so that sensors automatically check it out. Yes, this person is into the room, and they are on the switch on the AC automatically because that temperature is too hot currently, suppose that. And Next time, also sensor start the set-top box or TV should be on next time. Okay, because they know that that TV is basically next time. Even the lights even on, even whatever the lights available even on whenever they enter the room. And as you know that users are about the mood, that is happy and sad according to, and that is tired, suppose that. So what type of their previous category of songs is automatically available on phone. So phone that is basically using it, this category, and this much is playing onto the TV or even the whatever the available devices. Okay. And user mood, according to user mood, your light may be dim or, and this means adjustment of your lights according to your user preferences automatically done here. And this is the current scenario even this is the current scenario. If suppose all the things smart homes, this connecting devices, so this is basically is going here currently. So what are the major component in this? Major component of IoT is cloud, user interface, analytics, and gateways. So this is the major component, means sensor technology, smart and Arduino is basically used there. Communication technology for these communication, BLE and Wi-Fi basically. Machine learning is 10 ML algorithms basically using for that preference calculations. And human machine interface is basically is Android. So this is one communication between. So all these things basically using here. So abstract view of ML, that means load the data, train you find the best model. So load the data first, pre-process, very important part of machine learning, mean, standard deviation, PCA. Variance also be calculated here. And pre-process data, supervised learning, classification learning models will be built, and predict, integrate the data, and then model and prediction will be done. Okay, walking or sleeping or running, whatever the predictions. Next is how to architect your machine learning based on the IoT system. So that means some devices also be there connected with the devices, and like database is connecting business intelligence. I told you analytics like Tableau you can use, perform the complex queries analysis and apply the engines here. Okay, so prediction will be done here. Okay. This is the MATLAB scenario. This is the IoT analytics system with MATLAB machine learning. You can see that different figures are coming here. This is one figure, this figure, and this is another satellite figure is coming here. Okay, so that MATLAB basically is using here. Okay, so that means different wind history, tide level, and wind forecast is coming from, and historical wind and tide data is also available. So these data is coming to the ThingSpeak IoT analytics platform, and this ThingSpeak IoT is basically this data is going to the after the computations is going to the MATLAB neural network, and this is based on the machine learning. So on demand tide forecasting automatically available. Okay, so this is, you can see that analytics with the MATLAB here even. This is one case study. Again, other case studies of daily sport activity. And like one goal is to train the classifier to predict which is activity users are engaging in the based on the sensor data. So sensor data is collected from the devices. Okay, so all the four limbs and torso is basically is connected. So here, what is the requisite here? So feature engineering on the sensor data. First we can do feature engineering. We need to check the features here first. Then training the machine learning classifier. Okay, first we need to do the feature analysis, then next we will do the machine learning classification. So what are the data set? Basically 8 users all participate in the same 19 activities. Where is the 19 activities? Yes, this one next. So 8 users all participate in the 19 activities, each of 5 devices, 4 limbs and 1 torso, and have 9 sensors: XYZ, accelerometer, XYZ grossoscopes, and XYZ magnetometers basically is there. And data is collected in 5 seconds. In every 5 seconds, data is collected with the segment with the frequency of 25 hertz. Okay. So total 5 minutes of each activity of each user is calculated and collected here. So that 19 activities are sitting, standing A2, then lying on the back right side, on the right side or back, that is A3, A4, ascending and descending stairs, standing in elevators still, moving around in the elevators, walking in a parking lot, walking in the treadmill with the speed, okay, running on the treadmill with the speed, exercise on the stepper, exercise on the cross trainer, cycling on the exercise bike, horizontal, vertical position, even on the road. This is not be there, but we can also be calculate here. Rowing, jumping, and playing basketball. So all these 19 activities are basically monitoring here. And this 19 activities are whatever the file structure we need to choose. So file structure is in order to given above is 19 activity, 8 users, 60 segment. Total number, how many segments we are using it? 60 segments. And whatever the 5 units of torso is torso T, right arms RA, left arms is LA, and right arms RA, and left leg. Okay, right leg and left leg. And 9 sensor of each unit, X, Y, Z from accelerometer. Grossoscopes is XYZ 6 total, and XYZ of magnetometers. So total number of 9 each unit is basically calculated. So finally, when we put down this data analysis first, means how look like the data. So you can see that this parameter, actually you can see that from this graph, this from the accelerometer. Okay, and this graph you can see that X, Y, Z, three left leg accelerometer versus time is given here, and you can say that X level means blue line, green line, and red line. And whenever the blue line is there, so that means you can see the person is basically persons are basically using the X level sensor first. Okay, so this sensor is basically walking in regular pace here. Okay, and this spacing between the peaks also be constant. This you can see that this is showing the regular, but in these two scenario like X and Y, sorry, Y and Z is look like a similar one. Okay, look like a similar one. So that is walking in irregular space here. Okay, so slow, fast progress, and with respect to the equal spacing here, equal spacing means there are one showing it into correct form. So it's how that data is collected and how it look like with this data. Next, you can see this is the exploratory analysis of torso, of accelerometer measurement of torso with the time here. Okay, so that is you can see that these are the three parts. So different parts of three performing to all these three are separately. Those three axes are performing rather separately here. Okay. And next you can see that the devices, all three means all three axes of T, Y, and Z, and this is the plotting the plots here. Means how X, Y, Z of the particular person acceleration is basically correlating with each other. So you can see that person's acceleration of this is correlate, this is correlation, and this is the scatter plot. Okay, so that you can see that this diagonal is showing the basically showing the distributions of signal flow distributions of particular persons is in the Gaussian form here. Okay, and next you can see that these three figures are showing the centered of correlations. Means you can see that center of correlations of dimension of 3 persons here, and the scatter plots also showing the conditional relationships of the persons here between. So you can why we are plotting it. We are plotting from this we can see that the type of data, how the data is basically look like. Okay. Okay, so this data next exploratory analysis ED, after the EDA, we need to check out how many features we can do it here. Okay, so feature engineering phase is coming here. Different features engineering, different features basically we are using there. Okay, so means we here want to perform the different feature calculations, like feature engineering, mean, variance, skewness, and Gaussian is autocorrelation we need to calculate here. So with respect to autocorrelations with the walking, like autocorrelation of torso, acceleration and y dim of the walking is basically showing in this part. Okay. And feature engineering phase, autocorrelation of torso and y dim of the jumping. So that is, you can see jumping is just changing. Previously is high here, and this is, you can see that it's going to the down also be. Okay, lag. This is also be lag, and this is also belongs to lag. And next, finally, we will apply the normalization of each features of values between 0 and 1. Normalization, we want to apply it here, whatever value, whatever data we are capturing. And each 5 seconds segmented into single row of 1140 features totally. And reduce the dimension. So actually that is higher dimension features are there. So we need to reduce it. You can see that is total number of 1000, more than 1000 features we have. So we need to reduce the dimension. So we need to apply the reductions here. So whatever the playing role, expected values is basically going to the use here. So you can use here around 20 to 15 features, which is playing the major role here. Okay. Finally, that model predictions, historical data you can use here, like training and validation data. So that is training is for 80% and validation 20%. Modeling building that validate the models and optimize it. So first one is we need to build the model. So that is means validate the model first, then create the model and optimize it here. So this is the cycle is basically. And finally, whenever the model is built, so model is ready for productions, means next is used for the test purpose here. So there are two approaches we have used here. One approach is based on the creating the training data set and test data set that contain the shuffle samples of each users. So first we need to train the model on the data from the every users and predict the activities. Okay. Of every user in the test data set. So we have used the logistic regression here, support vector machine and random forest algorithms here. So this is, you can see that whenever we can apply the LR and SVM and the RF. So you can see that this is the final plot. I think this is not visible. We need to enlarge it. Just a minute. So this you can see that the training F1 scores accuracy and precision in recalls. Okay, of training that the analyzing of curves, you can see that. So that train and test data, you can see that F1 scores is looking like here. You can see that the training is around 1%, and whenever you apply the testing, so you can see that whenever the data is increasing, sample size increasing, so that is going to the top one F1 score. Okay. Same way in accuracy, you can see that accuracy is almost giving here, but that whenever we apply the sample size, so sample size is increasing, so it just look like a given to 98%. Okay, 95 to 98% accuracy. Very important part of two things here, like precision and recall. And precision, you can see that there is around 1%, 100% we can say. Whenever the training again applied here, so testing is applied here, so precision is about the 99 here. And recall number of training samples, you can see this is going to start with 94 and going to predicting right form. So it is look like means going to 99% means our model is built successfully, and predicting the things is also successfully from these points. Next, modeling approach 2 is creating the training set comprised of 7 randomly chosen user and test set the comprise of remaining users. So we are using the 7 randomly users here and train the model to predict which is activities previously unseen user are engaged in, not just for user and seen before here. So we need to predict here. The model means user are engaging with the activities or not. So here we are applying the SVM. You can see as F1 score of number of training samples and this respect to here. So F1 score, you can see that is a just, you can see this is the training is applied here. So, but whenever F1 score is lying is neutral, means accuracy, F1 score is giving the 20 around percent, less than 20% even. That is not the role is playing the sample size. Same for the accuracy even, and same for the precision and recalls. Okay, so that means from this point we can say that the SVM is not able to do categorizations of these two here. Walking, jumping category we can easily calculate here. This is a fun conclusion. These are the references of today's presentation, and thank you all. I think if you want to ask any questions, you're most welcome.
Dear participants, if you have any questions, you may please ask.
So in conclusion, we can say that IOP means machine learning is a basic use even in IoT for predicting the user behavior even. Okay, which is belong to the industry, which is belong to the health information, and which is belong to daily routine activities even. Okay,
So this is the new era, and the many research is going on. Even the security part, privacy, you can work it even. Okay. So if you want to ask any questions related to this, or so you can tell me here.
Sir, can you suggest some good research topic in IoT security?
Right now, you can see, as I told you, the privacy is one of the biggest issue, because our data is stored somewhere, and everyone that means capturing the data even our daily activities, and even the whatever the devices, even like look like, suppose that our voice is recording, our voice is recognizing, okay, our search pattern is recognizing. So security is one of the major issue. Security is, and security and privacy is one of the most researchers is working on the even here. So even the protocol issues also there. So there are big categories of security. So you can work on the which categories you need to check out. Means in which categories you are suitable. Okay, like you can apply the cryptography for privacy. You can apply the different privacy preserving technique. Okay, in IoTs even. So in which part you want to work? Like in the protocols, there are different level of security. In IoT protocol, even architecture, there are different level of security. So it's supposed that in the architecture, whenever the comes of cyber physical system automatically come. Okay, so that is the means collaboration of different area even. So you need to means here means basic of all these platform you need to study properly. Okay.
Okay, sir. Thank you, sir.
So training machine should be data. One question is coming, Supriya, from the Supriya, that for training machines, should data be labeled? Yes, actually for the training machines, data is labeling means, as I told you, the classification technique is only we need to do the training here. Means if suppose that if you want to apply the classification for building the model, so you need to apply the training. So labeled data is always very required. If data is not available, labeling, there might be chances that labeled data is not available. So we need to label the data. I suppose that we need to do the classification. So how we can do the label data? There are different mathematics available for this purpose. Like you can use a manual labelations that is basically done earlier. But the same thing is we can do it for if suppose that very small data if we have. So we can do the manual labelation on the basis of some theory, we can say that. Like I'll give you one example, like spam detection. Okay. So in the spam detection, we know that email spam detection, we know that there might be some links and that might be using, we can check the behind the links, whatever the things basically, whatever the text basically stored. So we can say that on the basis of these category, we can say that the email spam is not okay, and coming from the legitimate user or not. So we can say that we can divide it one into the category, one into the storage that is belonging to the email spam category. Okay, so if suppose that we can do the manual labeling of data, it will take time. So instead of doing this, we can use some auto labelings here even. So sometimes some data mining techniques even we can use for labeling even. Okay, so for this also be using for this purpose even. Labeling of data is one of the major issue in data mining, and even one research is going in means imbalanced data set for this purpose. You can also be working here.
Thank you, sir.
Any other question? Any other questions if you want to ask?
No, sir, I don't think now anybody is having any questions.
Okay, thank you.
Okay, thank you so much, sir. It was really nice talk, and we are really overwhelmed by your presence. Thank you so much for accepting our invitation and taking the session. It was really wonderful. Thank you so much, sir.
Thank you. Thank you. Okay.
Yeah. Dear participants, attendance link has been shared in the chat box, and the link is still open, so you can mark your attendance. And now we'll be having a lunch break. We'll meet after the lunch break. Thank you.
Sir, am I audible?
Yes, you are audible.
Yes, madam, you are audible.
I think sir has joined. Tuhin?
Yes, sir.
Yeah, hello everyone. Yeah, I have joined. Just somehow I was in a meeting, so I'm not available. So we can proceed.
Tuhin sir has joined. You can start.
Welcome to all the participants for the third session of today's FDP. 1 week online AICTE Atal Faculty Development Program on IoT and its applications. We have among us Dr. N.S. Rajput sir, sir is an associate professor in the discipline of Electronics and Communication Engineering, IIT BHU. He did his PhD in Neural Processing Systems from IIT BHU. He has published more than 50 research papers in reputed journals and international conferences and seminars. He has 17 plus years of teaching experience. His area of interest is various applications of neural networks, machine learning, artificial intelligence and communication and computational networks, especially Internet of Things and cyber physical systems. Sir, we are very thankful that you are here to enhance our FDP with your presence and share your knowledge. We welcome you.
Yeah, okay. Thank you so much. Just give me a minute so that I can just start. Meanwhile, you can give me permission for...
Yes, sir. You have been made co-host and now you can share your slides.
Right. Just give me a minute. Okay. Right. Hello, everyone. While we will proceed for our interaction, I would look forward to see you people, how you people are doing and what is our gathering. So I will suggest if participants could also switch on their computer cameras and interact in a normal way. So can we quickly switch on our cameras so that we can have some interaction, and then we decide the direction in which we will be having a discussion. So everyone, please switch on your cameras. Let's have a bit of introduction and then we move on. Right. So can we see the participants? I think right now all we are seeing is the number of hosts. Okay. So hi Tuhin. Tuhin, have we permitted the participants to switch on their cameras, or we have blocked them not to switch on?
So they can chat with you and they can unmute themselves.
Okay, but they cannot show themselves.
No, sir, it's possible, but because of bandwidth problems, sometimes it takes trouble.
No, it is the bandwidth problem of the concerned participant, not us.
Yes, sir. So, not us.
So at least as I can see, we have almost 80 participants. So I really want to see at least 20 faces switched on, because I have mostly seen that they connect and then they go off. They least bother about what we are speaking. So if it is such a case, then there is no reason why to spend our precious time on them, right? So dear participants, please switch on your cameras. We are sincerely and carefully interested to help you.
Please write in the chat box that
Yes, I've written.
Participants, please switch on your camera. I am just writing.
देखो अभी सब गायब है ना, सब बंद करके चले गए खाना पीना खाने.
Sir, yes, most of them.
Good afternoon, sir.
हाँ नमस्कार. नमस्कार सर.
Sir, namaste.
आप कहाँ से हैं?
Sir, I am from Gwalior and I am assistant professor in Madhav Institute of Technology in Gwalior.
अरे very good.
Madhav Institute of Technology and Science, Gwalior.
Right. Amazing. Very nice. So how has been your experience with these during these sessions?
Yes, wonderful, sir.
Okay. So
was
what kind of
informative.
research are you pursuing?
Pardon, sir?
What
Yes.
kind of research are you pushing?
Sir, because of my research area is image processing, sir.
Okay. Right.
Yeah.
Very nice.
So I'm also interested in work on IoT also as well. So that's why I'm joined.
Okay. So what is your typical application for which you have been using your image processing?
Sir, retrieval system. So I'm working on a image retrieval system.
Okay.
Based on soft computing techniques, sir.
Right. Very nice. All the words are quite complicated, huh? So
No.
Okay. Can we meet other participants also? Hi, Karuna. Karunal Kumar. Chunilal.
Hello, sir. Namaste.
Yeah. Hi.
Hello.
Hi, Mr. Kamani. From where are you? इतना बड़ा मास्क क्यों लगाया है? वहाँ सामने कुछ लोग बैठे हैं क्या?
कौन खाते रहते हैं सर?
Okay.
Right now, I am from
Right. Your voice is not audible. Probably sound is not able to travel through the air. You have blocked your voice from mask. So how would we listen? Yeah, now speak.
Sir, I am from Anand.
Right.
SMC College of Dairy Science.
Okay.
Anand.
Okay, your voice is still not very good, so maybe there is some difficulty with the microphone. Yeah. And how about hi Ashish? Namaskar Ashish ji. Ashish ji.
Ashish ji, please unmute yourself. I think it's Anil Kumar Sharma, sir.
Yes, sir. Good afternoon.
Okay. Hi.
Good afternoon, sir.
Good afternoon, Anil ji. How
Sir,
are you?
I am Jesudas from Satyabama University.
Yeah,
Chennai.
very nice. So good.
Nice meeting you, sir.
We have just started to talk, so we will see. So what kind of application are you working on?
Sir, my area of interest is cyber security.
Okay.
So I am concentrating on IoT security related domains.
Okay, so can you tell me anything about recent security breach which might have occurred in recent IoT?
Recently, automotive hacking is at its peak, sir. Automotive hacking.
Okay.
So you can hack the smart cars.
Not only that, recently malware hacking all these sensor nodes was released.
Yeah.
10 days back.
Yes.
It had affected almost 5 million IoT devices across the globe. So it was a major attack on IoT systems.
Yes, right? I have studied that 1 month.
Okay.
So I'm not able to recollect.
Right. How about hi Karthik?
Yes, sir. Nice, sir.
Yeah, hi Karthik. From where are you?
I'm from Ramakrishna Mission Shikha Mandira, Computer Center, Bilumot, sir.
मास्क से आवाज तो आनी नहीं है, ये अगर हम ऐसे ही अपने स्टूडेंट्स को भी पढ़ाते हैं तो नेचुरली आवाज नहीं जाती होगी उन तक।
ठीक है सर।
बेहतर है रूम लॉक करें, किसी को आने मत दें, लेकिन उतनी देर तो फ्री ब्रीथ करें, ठीक है?
ओके सर।
Now tell me about yourself.
My name is Kartik Pal. I am the center coordinator of Ramakrishna Mission Shikha Mandira Computer Center, Bilumot.
Right. So what kind of research are you pushing?
Yeah, sir, not a research center. It is just education center for educate student for higher level IoT for student.
Okay, so how would you be benefited from this FDP? Okay. So anyways, let's start. I would look forward if you people keep your cameras on, right, throughout the discussions. It would be as good as like we are talking to each other. Okay, so I will suggest that. So the very first point which I would like to just emphasize is what kind of pre-processing do we expect? My topic of today's discussion is about pre-processing in IoT paradigm. Okay, so the first thing I would like to know is what kind of pre-processing and processing do we expect in IoT paradigm? Any one of you can just tell me this.
I have faced the problem of imbalanced data. I'm doing the work in IoT security, so that is a big problem for me because most data set, first of all, they're very small, and then when I decide to go into it, then I start having a problem of having imbalanced data. For that, there are few algorithms that I am trying, like scat boost and rust boost algorithms for and SMOT. But that is one of the big problems, that we have imbalanced data. First of all, already the data is very small. Then we have imbalanced data. And then if by somehow I get up to the next step, then the problem begins that one attack class is always larger and the small attack class is so small that causes the precision and recall problem for me. Because even if that small attack class will move forward, it will cause a damage. In real world, it will cause damage. Right now, I'm in a simulated world.
Even one single attack would make the difference.
Yes. So that is 3 things that I have seen in pre-processing of data alone before moving forward.
Right. So how do you implement this pre-processing on the data set being gathered in real time? How do we do it? For example, in real environment, you are capturing some data, right? So what do you think? How can we actually capture such data and ensure that it is proper?
So I think, sir, it is coming from different kinds of sensors.
Right.
So I'm audible, sir.
Yeah, we can listen.
Yeah. Yes, so definitely the data will come from the different kinds of sensors, and we need to definitely pre-process them to get some valuable data from them.
Okay. So nowadays a new paradigm people are talking about is edge computing or edge processing or feature extraction on the edge. What is that? I mean, it is just a casual general discussion, not to be very specific. How do you visualize processing on the edge? Anyways, when we talk about IoT paradigm or IoT environment, what are different components which you think should be considered, or what are various components in the complete system? We will start with basic sensor node, right? So typically each sensor node will be connected with multiple sensor devices, right? So sensors will be capturing the information, right? And from these sensors, we are gathering the data onto the microcontroller, right? So for example, what microcontrollers can we think of?
So kind of processing.
What
device.
kind of, right? For example, what kind of open source popular microcontrollers or processors do we consider when we design an IoT system? Can you just give me a small example? Anyone? Rubal Yadav ji hain apne saath na. Hello Rubal, can you listen to us? Okay. Tanushri, can you listen? You can unmute and speak. Tanushri. Tanuja. Narayan Karmakar ji. Hi Narayan.
Hello, sir. Sorry, sir. I don't know, sir. I don't
Hello.
have answer.
Now you are all right. So my question is, when we work on IoT systems, what kind of controller or processor devices can we think of? Where would you create a sensor node? The very first thing is that.
So Arduino boards or Raspberry Pi for interfaces.
Right, very nice. So, and which one is the most powerful sensor node related device these days? I mean, which is very, very pertinent, and someone cannot live without that. If you are not using it, I would suggest
ARM processors.
One, of course, processor itself will not be good for us. We require a single board processor, controller, or device. So in that category, ESP32 is one which comes with even Bluetooth connectivity. It comes with Wi-Fi connectivity, and it is a well minimized or physically miniaturized IoT device, which has many features like sleep, energy saving, and many other platforms. Okay, so if I consider ESP32 or Arduino or Raspberry Pi, these are the very basic controllers which can be interfaced with various sensors. Okay, so when we talk about a processor and pre-processing, now number of sensors might be giving you inputs on that sensor node. For example, Arduino. For example, okay, let's take Arduino, right? So we are gathering the data there. Would the crude data itself or the raw data itself be forwarded to the gateway or elsewhere? What do we do?
So it has to be converted to electrical signal.
नहीं, electrical signal तो वो already रहता ही है. Just a minute. Hello. हाँ. Right. So basically, the sensor data which we are capturing, it may be analog or digital data, right? The analog data is in the form of voltages, right? So to us, that data is simply a value, okay, which is eventually converted in machine language and is transmitted, and from the libraries which we use in sensor nodes, right? Eventually, we will convert it into equivalent values. To us, this internal processing is not a difficulty. Rather, we will say that whatever value we have captured from a sensor node, that value is available with us, right? So one thing is, when we are capturing real-time data at a single point of time, that data is only one single vector, right? How would you process any single vector for necessary anomaly detection or balancing or something else? How will you correlate your values, instantaneous values from a sensor node with respect to the statistical distribution of the data with which you have or you are planning to process it? Any idea, or have you ever thought about that? For example, if we are saying that you have lots of data, Tuhin was saying it is balanced or unbalanced and very complicated data, right? The point is, she can know whether her data is balanced or unbalanced only when she has gathered all that data, right? So if you have a whole bunch of content data, multiple vectors, then only you can say that few are belonging to major attack. There are some minor attacks also which are also going on in real time. Okay, but in general, how would you actually know whether this is an attack? How would you capture its signature? And how do we define signature in a data set or in an IoT environment? Can we say something about the signature of the response which we are capturing on the sensor node? We can call them as features. And what are features? Features are respective value of that sensor parameter. For example, I work in the area of gas sensors, so I sense same gas by using a sensor array. For example, 16 sensors, 8 sensors, or whatever. So what happens? Each single sensor senses the same gas with different response magnitude. So if I have exposed my device with, say, LPG, then sensor 1 may give me some value as 2.5, other will give me 3.7, another will give me 1.8, and so on. So if I plot a point graph, right, and I am just plotting the data points I have received from respective sensor element, right? So what would that be? It will have certain magnitudes. And if I join those dots, it will be a kind of pattern, right? So especially regarding Tuhin, I will say, while I am receiving various parameters, in fact, during cyber attack, what kind of parameters do you consider? How do you identify that this is an attack?
So when I look at the TCP value,
throughputs.
so in my case, I've seen that I was seeing HTTP flooding attack. Then I saw that in some of that we call features, the attack, let's say the attack that has happened, the feature was very different from the usual HTTP that was happening on that network and the device.
What is that HTTP parameter which you observe? Attack तो हो रहा है, attack होता कैसे है मुझे तो यही नहीं पता. मतलब इट्स नॉट माय एरिया, तो अटैक मुझे पता भी नहीं होता. सो बेसिकली अटैक कैसे पता चलता है कि क्या है? हाउ डू यू आइडेंटिफाई दैट सर अभी जो हो रहा है वो अटैक हो रहा है?
Generally packets delay.
पैकेट डिले कोई अटैक नहीं होता.
Some DOS DDoS attacks are there.
अरे वो तो बहुत पुराना हो गया, अब कोई नहीं करता वो. एनीथिंग एल्स?
Desired information which we not get.
ये तो ओवरलोडिंग ऑफ अ सर्वर हो गया. जैसे फॉर एग्जाम्पल you are receiving connection requests on your server, right? When would you say that this is DDoS or it is DOS attack? Generally, if it is automated attack from the same IP address, connection request will come again and again and again and again 1 million times. So you will immediately say that there is one specific IP which is trying to connect to my server so many times that every session it is capturing. For example, it is opening browser. It has opened 10,000 browsers. And each browser connection request has come only from single IP. So what will happen? Your server will of course say yes to those connections, and since it is the same IP, you will identify that it is DOS attack, right? Denial of services attack. So someone is trying to connect on my server. Suppose I have 10,000 concurrent connection capacity, or if I have 5,000 or 1,000 connection capacities, right? So if I can have those many concurrent sessions, so I can only serve 1,000 users at a time, right? However, during such cyber attack, such 1,000 connections have been initiated by only a limited number of IPs, or 5 IPs or 10 IPs, or maybe multiple distributed IPs, right? So basically, first parameter of attack
bandwidth
is my IP address. What is the IP address from where I am receiving the request to connect on my server? So if I only consider this thing, then number one, this IP address from where my connection request is coming, I should cross check whether the IP addresses are different or within the same range, or what is the probability of this IP address not being a genuine IP. Because usually when I will open, it will be opened through my global IP, right? So even it sometimes so happens that suppose I have opened a server and I am connecting it to some remote server, and at my end on my network there are 10,000 users who are accessing various websites from the same domain. So every time same IP address will be shown, and if there are number of users who are connecting only to a particular website, now to that website it would seem that all of a sudden 600 persons are trying to connect through a single global IP, right? So what will happen? It will immediately be identified as an attack. So what I meant is, this was one parameter which I could just now visualize that must become a parameter to detect whether it is an attack or it is a normal thing, right? Similarly, there will be number of other parameters and values which will be identified as parameters to generate a signature. For example, another thing to verify is what many folders some user is trying to get into, right? So if it is an attack and if it is trying to get into your system, it will not only go to your respective websites specific folders, user related folders or folders of interest for the users. Rather, it would try to go into such folders which are actually not intended to be used by a user. For example, if I have to navigate through some website, I will go to its first link, then I will go into some other folder and few more folders. I might watch some videos, or I might try to watch some images, or elsewhere I would like to read and see through some text in a web page. Okay. However, when a hacker will come, would he be interested in your videos or images? No. He would look forward to go into some private directory, right? So his attempt to enter into some other folder will be different. So another parameter of signature of or importance may be where the next connection is trying to be established into after he has entered into my website. So there are some specific folders which are private, but sometimes they remain open for access, and through them the hacker may actually navigate into your secret folders or folders of of internal machine, right? The backend folders. So it will try to get into by that. So second signature will be a time series based signature. At first, we will verify whether he has accessed through multiple connections are coming from multiple IPs or from the same IP. So this is one criteria. Another will be where is this connection actually entering into. We will see that there are some specific type of viruses or malware which tries to enter into different types of folders which a normal user will not go. So you will check in next subsequent connections request, HTTP request, which folders did he try to go into. If it is a normal way of folders in which usually a user gets into, for example, if you are into a Facebook, so you will go into various albums rather than going into or searching and looking for such folders or names of folders or extensions of folders which are usually not required to be clicked by a user. So second parameter will be how would you know whether it is an attack, a way to discriminate such connections. So since I am not a man from cybersecurity, so I am not very competent to actually keep on giving many more examples, but to an expert who is all right in such applications, I can visualize these two typical cases, right? Then in the same direction, now we come back to our point. We were saying what is edge computing or edge processing on the edge. So हम क्या करेंगे? How to know whether this is an attack or this is something else? We will place AI module or some signature verification module on the edge itself, right? So how would we do local processing on the sensor node? you will write a small software-based program in Arduino or Raspberry or ESP32. ESP32 is not exclusively programmed, rather you can directly write the same thing on Arduino IDE, so that is also not a difficulty. But number one, you are capturing the data. If you want to identify whether the connection is coming from same IP or some other IP, for each next connection you can verify or maintain a list of IPs from where such connections are coming. Yes. Okay. Then the second thing is, if you have to maintain a time series, then in the local memory you can retain certain length of data, right? That length of data will become a time series. So how do you analyze a time series? Now there are multiple algorithms, right, which help you analyze a time series. They help you monitor the pattern by which a data is changing. So usually if a new user will enter into your website, he will look for images, videos, text, and related content, right? So if this is the way some search is going on, okay, it is a genuine one. But if it is trying to enter into some specialized folder which is not generally useful to a normal user, you will identify it as a as a mechanism by which you should as a indicator which you should stop. So what we do, we actually apply or implement a small AI module into IoT device or into the sensor node itself, right? So for example, if some data is coming from multiple physical sensors, then in that case, you will continuously monitor the kind of data which is coming and the way the data is changing. Suppose this data is about the presence of gases in the ambience. There should be a pattern, right? Suppose values of gases is changing. The way carbon monoxide is increasing or decreasing, if there is some correlation with respect to temperature and humidity, that whenever carbon monoxide increases, usually it is due to fire, and because of the fire some other parameters should also increase, and while they will also increase, at the same time temperature should also start increasing in the ambience. So what happens, we have identified few parameters which will be changing more or less in a correlation or in a correlated manner. So this is where once again we implement AI modules as a pre-processing devices to check whether this is a normal trend of data which is changing, or if it is artificially injected data values. For example, your sensor readings are, some of the sensor readings are changing, other sensors are not changing, whereas they have mutual correlation. Whenever one parameter increases, other parameter should also increase. So in this way, especially in the IoT paradigm, when we talk about data pre-processing, it is not merely pre-processing of the data. In fact, even sometimes from the security point of view also, you can monitor the data, the patterns by which data is changing. So in fact, this was the primary thing which I wanted to show to you people or bring to your interest, whether in what way we can actually consider few things as important. Okay. How do I minimize this strip which is being shown? Are you able to see my screen?
Yes, sir.
All right. So how do I remove this upper strip?
Sir, in Edge it will show. So you can just scroll down.
Acha, edge will always be shown.
Yes, sir. As far as I know, it shows.
नहीं ऐसा कुछ होता है, उसको हटा देते हैं.
Sir, you can use here in bottom left hand side these arrows. I think plus and minus, left hand side bottom. Yes. No sir. No sir. No sir. No sir. Bottom arrow.
Bottom arrow, bottom arrow, bottom arrow, bottom arrow. कहाँ पर bottom arrow?
ये सर वो प्लस माइनस के नीचे. माइनस के नीचे सर.
माइनस के नीचे.
ये?
Yes.
ये तो रीलोड के लिए होगा कुछ.
नहीं रीलोड नीचे है सर. नहीं सर ऊपर ये जो एरो बने हुए ना सर.
सर रीलोड के ऊपर और माइनस के नीचे बीच वाला जो है वो एक्सपैंड कर देगा.
नहीं, इससे तो पेज एक्सपेंड हो गया मेरा. मुझे ये स्ट्रिप हटानी है जो आप लोगों को भी दिख रही होगी. दिख रही है ये?
यस सर. वो तो पीडीएफ है.
नहीं. अच्छा, जूम का स्ट्रिप आपको नहीं दिख रहा?
नहीं सर, जूम का स्ट्रिप हमें नहीं दिख रहा.
अच्छा, मेरे यहाँ बड़ा तेजी से दिख रहा है.
सर आप उसको मिनिमाइज करिए. ऊपर वो जो जूम की
हो गया
स्ट्रिप में माइनस साइन.
अरे हो गया. मैंने पता नहीं क्या किया, लेकिन कुछ हो गया. अब बाद में प्रॉब्लम आएगी तब देखेंगे. ओके, एनीवेज, तो मैं जो बता रहा था वो ये बता रहा था कि वी रिक्वायर अ प्री प्रोसेसर, ओके, while we transmit some information into a sensor node. So while we transmit our information into a sensor node, we can have something like this. One thing I would like to inform you all that actually I wanted to show you all regarding the data transfer thing, and my touchpad is not responding. Why? I don't know. Probably there is some issue on this, so there there is some device problem. So my device pen is not detected. Anyways, leave it. So I wanted to actually tell you about analysis space. What is an analysis space? For example, if we have multiple pages which are stacked one over the other, so can we see into other pages? No, because the very first page we will be able to see. However, if I can rotate it in a way so that the pages are now parallel, or I can see on the edges of the pages, then between these two pages I can see through, right? So I mean, when you have some data or some information is coming in, you can rotate it in such a way so that it will form very visually analyzable cluster. Okay, so what happens if there are pages like this, rotate it like this so that you can see them. For example, one very popular rotation or analysis space is principal component analysis. Okay, if I talk in a layman's language, for example, taking logarithm of some number will convert it into some new domain. What is that domain? Initially, say there was a mathematical formula 2 into 3. So if I take logarithm of it, so log 2 plus log 3, so the multiplications are converted into pluses, right? The numerical value was converted into log values. Then I can add log 2 and log 3 together. So the resultant addition of log 2 and log 3, what I will get. So this logarithmic domain is another analysis space into which you can analyze your data in a better manner. For example, multiplications and divisions became additions and subtractions, right? So in this domain, I can actually analyze. Now, once I have done the processing in this new domain, once my processing is over, I can bring this values back into original domain from where we had transported our information into that, right? So can you predict what is the advantage of such thing? Can you predict why did we do that?
We are resource constrained, so we are trying to do it in small way.
No, we are not. Why did we do algorithm of our logarithm of the multiplication equation? So that in that analysis space, I could analyze, do the calculation rather more easily. Okay. Similarly, when we have certain data set, we move it in a way so that in the new domain, things are rather more visible. So the point I wanted to emphasize was that in the new domain, I have more clarity. And yes, so the first thing is, in one of our research papers, what we did was we took the raw sensor responses and we did the basic signal conditioning like baseline manipulation, normalization, and whatever. After that, what we found is that the raw data is not actually easily analyzable. Rather, if I can transform it into analysis space, principal component analysis space, then in that domain, I can see very clear clusters. For example, in these graphs, you can see this is my sensor response. As I used to increase the gas sensor concentration, responses of sensors started changing. The way sensors were changing to a particular gas, 4 different sensors started giving responses. And initially, when we plotted the raw sensor responses, the raw sensor responses, as you can see, are seen quite merged together. Although there are some specific lines, but what is a cluster? A cluster is a sphere which is formed. So what happens is, if I will create one sphere for this data, starting data and end data will become the diameter of the sphere, 3-dimensional sphere, and my data can be anywhere, right? At the same time, if I talk about some other response, then for this other icon, for example, earlier I took the xylene icon, which was a circle. Now I am taking EMK icon, which is a small square shaped. So now what? If I will create a sphere, a 3-dimensional sphere by taking the diameter of highest and minimum value of the square shaped data, this will form another overlapping sphere on the other sphere which was formed with circles. If some data is found overlapping within the spheres, then within those spheres, since there is maximum overlapping, it is very difficult now to actually predict whether this data belongs to sphere 1, which is class of 1 gas, or belongs to some other sphere which belongs to class 2, right? So they are overlapping and confusing. So what we did, we transformed the data into some another analysis space which was principal component analysis space. We pre-processed through by collecting the whole long data set over the whole range of experimentation, and we identified certain statistical parameters. Now, you see, for example, if I have taken logarithm of some mathematical equation, now everything is in the log form, right? Now, if some new number is to be added into the log form, number one, this first new parameter, new number, has to be first converted into equivalent log form, then only in the logarithmic logarithmically converted equation, then only this parameter can be added. Okay. So what happens, once I did the principal component transformation of my gas sensor responses by using AI. Now, if I placed this AI trained PCA converting device into my sensor node or microcontroller, when a new data will come, this will be a raw data rather than PCA transformed data, right? So this cannot be processed from this SPA transformed high quality, high performance ANN data. So what we did, we implemented another neural network before the actual classifier network, which we called as pre-processing network, right? In this pre-processing network, I actually trained another AI engine which will transform my raw data into equivalent principal component analysis data, right? By using the statistical distribution parameters which my whole set of experimental data had taken, right? So what happened? Now, since I have trained my second classifier network, neural network, to correctly classify or predict a particular gas or odor, it is a kind of logarithmic equivalent in a simpler way. So what happens when I transformed, I have to transform the raw data into this as well. So what happens? The real time raw sensor response is converted into equivalent principal component analysis space compatible component by using a pre-processing network, right? So now what happens? I have trained a very high performance classifier at stage 2. Before that, I have added one stage 1 neural network which will convert the data into PCA. So raw sensors will feed data into my stage 1 preprocessor, which will convert my information into suitable data for input into the classifier, which operates in principal component analysis domain, and I get excellent result. What I mean is, this preprocessor stage, which helps me convert my raw data into principal component analysis domain compatible data, this is an AI engine. Now, this classifier may be on the cloud or elsewhere. My raw data is being pushed into microcontroller. So microcontroller will have its own small network on the edge. Therefore, on the edge itself, my raw data will be converted into PCA component, PCA compatible data. And therefore, whatever data is coming is transformed and converted and then pushed into the cloud for further processing, or a local classifier can now conveniently do this with very high efficiency, right? So this is the thing which I actually wanted to introduce to you all, that you can design AI engines, classifiers, and other kind of things which may be very efficient, but for their high efficiency, they operate in new domain. So you can choose Fourier transform, you can choose principal component analysis, you can do wavelet transformation, you can do many different kinds of transformations, right? And those transformations actually will require you to pre-process your data so that it is compatible to the advanced classification method or AI method which you are implementing. Nowadays in the IoT environment, no any transformation or process can be performed without the use of AI. But when AI operates, it may conveniently take your normal data into specialized data. There you will process, and for that you will have to transform your original data. This transformation is now being considered as pre-processing. Earlier, pre-processing of data was considered as normalization, baseline manipulation, and number of different types of the pre-processors. Nowadays, pre-processor is another AI engine or intelligent method which will extract inference-based modified feature which will be compatible with your actual analysis engine implemented in AI usually. Okay, so you should consider now high-end analysis spaces where you can perform things very well. However, for those domains, you may require a pre-processor stage to convert it into that domain. Okay. So one of this method was published by us. Then we had another unitary response model in which we once again proposed another type of more efficient analysis space, and into that analysis space, for that we designed a compatible pre-processor also. So unitary response modeling pre-processor. So we designed another processor, and that processor is now feeding it into unitary response model based classifier engine. So in this way we published another paper. Then we also recently published another paper in IEEE, which was an international collaboration. So there also we proposed another virtual multi-sensor transformation analysis space for classification of gases and odors. What was that? So actually the raw sensor responses were converted into another kind of sensor responses where the data is mutually separated. It is quite far away. So in fact, here you can see that we have compared and considered different types of normalization techniques, relative scale, 1, 2, 3 different types of, we have added references also, auto scale, range scale, and many different kinds of modifications. However, we published our own new method, normalized sensor response based technique. So in this NDSRT method, we created virtual sensor responses. What are virtual sensor responses? For example, sensor 1 is S1, a physical sensor output. Sensor 2 is S2, another output. Now I have only 2 sensor responses. What I can do, I can create sensor response S3, which is S1 plus S2. So this becomes my third response. Then I will take another column, S1 minus S2. So S1 and minus S2 is another column. I will calculate that, and it will become my fourth sensor response. So in this way, within this, among 4 sensors, S1 and S2 are my 2 physical sensors, two parameters have been created by using S1 and S2. One is, third parameter is S1 plus S2. Fourth parameter is S1 minus S2. Fifth parameter may be S1 divided by S2. Sixth parameter may be S1 multiplied by S2, right? I mean, different combinations can be done which will effectively reflect similar type of data distribution. If you will use that, so out of 6 parameters, 2 are real, 4 are virtual. In this way, in 6G IoT paradigm, in where intelligent IoT is being implemented, you will not only work with real sensor responses, but another form of response which has been curated from the physical sensor responses itself, but that response is rather more meaningful than the physical responses. In this way, nowadays we have virtualized environment to make things rather more efficient. Okay, so that was another paper. Then we also published another paper where we published that normalized difference based classifier for efficient discrimination of volatile organic compounds. So here also we published different a method, normalized difference sensor response technique, which I was talking about, to classify another set of data to be rather more efficient. So with this, I come to my conclusion. How do I show everyone? We had pressed to hide. Now, okay, if I stop sharing, what happens? Okay, good. So now we are back on the screen slide. So what I wanted to emphasize is you can choose any AI-based efficient method which will give you a very high performance. Now on the sensor node on the edge itself, you should implement this AI model. But to this AI model, original sensor responses will not be compatible. So you will have to implement and add another AI engine in cascade so that more inferences can be drawn. Now, with this description, let us come back to our original example. For example, we were observing the way by which IP addresses were coming. So I can plot them on certain coordinate scales in 3 dimensions, and I can keep on placing different real-time IPs which are coming into certain domain, certain sphere, or in the form of a cluster. So what will happen? While it is being plotted, if it is not within that cluster, it's fine because it is random data. So it may be placed anywhere because IP addresses are coming from all over the globe. But if there are some millions of connections or thousands or lakhs of connections within a same small sphere, we will have to cross check whether these people are real physical people coming from the same organization or this is an attack. So a small AI engine can be implemented where mutual separation of different IP addresses can become a parameter, right? So it will, the way real-time inputs are coming, you will measure their distance, for example, Mahalanobis distance or some other distance with respect to some other IP address data, and check whether they are dissimilar and how much similar they are. In this way, in real time, we can infer, measure, and forward the connection further, or we may block this connection. Sometimes, for example, it so happens that you are on a network and multiple connections are being made. And suppose this is from the same domain, then you will say that since it is the same, the chances are that it is an attack. Number of connections being generated from the same will give you an alarm. In this way, train a small AI engine to measure such parameters. These parameters are now being considered as more informative. So information will be forwarded only when we have verified certain feature characteristics in the sensor nodes. Okay, so that was my point. Nowadays, basic statistical pre-processing is not as hot as you would like to transform your raw data into a new domain, which is rather more visible, effective, and efficient. So as the lecture has been recorded, so you can once again go back and check my references, go through those research papers and identify in which way AI and ML can give you rather more effective decision maker. And for those effective decision makers to implement this thing in real time, how can you do that? Okay, so if I talk about the way an attacker is navigating through my website, okay, what kind of folders it tried to open, based on only a few, 1 or 2 or 3 steps, you can immediately predict that a normal user would never have gone into that. But in this case, he is jumping to various folders very quickly. Okay, so if a only 3-step time series monitoring AI model can be implemented on the sensor node, you can immediately predict whether this connection is a bona fide connection, genuine connection, or this is an attack. Okay, so this was my view on the typically data pre-processing approaches for 6G IoT paradigm. Nowadays, this processing is not routine processing, rather AI-based processing. And for AI-based processing, you will be using AI tools. For example, TensorFlow Lite. In ESP32, you can implement TensorFlow library, right? But all the algorithms of AI algorithms available in TensorFlow cannot be implemented. But a limited number of libraries and AI models can be implemented into IoT nodes like ESP32 or Arduino, right? And so if you have designed your primary AI model into main platforms on Python, it may not be actually transferable into a sensor node. So that is a special thing. Remember it. You have to identify the algorithms which are compatible into your choice of sensor node. And that is why sometimes people are invariably going for Raspberry Pi. Raspberry Pi is a Linux machine, so which hosts complete Python library. So any and every AI model can be implemented and utilized. Okay. So with this exposure, I would stop, and now we can take some questions if you have.
Participants, if you have a question, please ask.
Yes, we have many participants. Only a few have switched on their cameras. So it is difficult to know whether they would have some query. So Ujjwal, hello Ujjwal.
Yes, audible. I'm.
Yeah, Ujjwal, you do you have some query or some question?
No, sir. No. Sir.
Why? You have been listening with so much interest, and now you are
No,
not
sir.
having a question.
Actually I joined late and
Okay.
I joined late.
Okay. Then who to ask? Tanushri, can you unmute your mic?
Yes, sir.
First, tell us what good were you eating?
Sir, dry fruits.
Yes. So I thought I am spending energy and she's eating dry fruits.
Sir, because
So
I have to spend energy in the class as well. No? I have to go to take class also.
So it was interesting to see. So probably that was the source of my energy as well. Okay, someone is eating, so someone is getting the right amount of energy.
Yes, sir.
So what query do you have?
No, sir, nothing. It was a good session, sir.
Okay, okay. Anything else? Tohin, yeah.
So actually, I am on the stage of pre-processing. So, like, I have there are data sets present. So there is the problem in part of imbalanced data. There is also part of missing values. So would you suggest that I drop that column in the features?
No.
Or should I put a fixed value to it?
No.
Or a null value to it? Or what should I do?
There are two things. One thing is, can you tolerate the absence of that data? If you want to, no, there is one thing. If you can tolerate the absence of data, then you have to generate that data. One thing, if this is absence of data is due to some wrong connection or some issue, you can anticipate that data with previous value of data, or you can place some value in the absence wherever, say you have typically given number 109 and you have observed that usually 109 rarely comes. So the good way is we will choose or substitute some value which seldom occurs. Okay. So either you can fill it up with some matching value if you think it was failure of a sensor. So the way we place a capacitor in parallel into the line, so that if there is some fluctuation of data, at least this capacitor will maintain the voltage level.
Right.
Similarly, if you think that because of some unavoidable error there was a miss on the data, you can refill it. Suppose there was a series of numbers 107, 108, 105, 107, then there was a missing data, and then after that once again it is 107, 109, 108. So you are observing that there is a continuity in the pattern. So for such discontinuous things, rather than eliminating that row, you can substitute by using another AI model.
Okay.
Right? It will maintain the same kind of input. Okay. Or if you want that it should be replaced, you can create some cross-checking kind of values, correlation between other parameters. If one parameter changes, other parameter should also change. If it is because of the error in the transmission, and if some other parameters have been captured, based on those other parameters, you can always train another AI model which can correlate and generate similar type of authentic data, which you can always say that probably this data was missed, but actually it is not a data which was not generated. It was actually generated, but our network AI model could predict it. So maybe that can help.
Thank you, sir. So no more questions then?
Yeah. Huma, do you have some question? Okay. Okay. So, okay, I think we can stay connected whenever any one of you wants to take up some other problem into the similar area. We can stay connected. All of you people can connect to your program coordinator and connect back with me. Okay.
I thank you, sir, for giving us a valuable time for becoming a.
In fact, I will thank you, Tuhin, to your organizers especially, because my previous lecture was rescheduled. Today, my lecture was also about to be rescheduled, but okay.
But we look forward to interaction with you, sir. So we are looking forward to interactions.
Yes. In fact, this is not just an interaction. I would say that this is just the beginning. So it was nice to meet you all, and let's stay connected. So let the series begin.
Sir.
Thank you, sir. It was really nice.
Thank you very much, sir.
Have your inputs.
Yeah. Okay. Bye bye. Bye everyone. Bye. Thank you.
Thank you, sir. Thank you so much, sir.
Bye bye, sir. Bye bye.
Bye bye. Bye.
Thank you, sir.
Yeah. Bye.
We will meet again tomorrow. Thank you for attending. Hope you have filled the attendance sheets.
Participants who are listening to me tomorrow 10th session, please be present on time. And I have some important announcement regarding tomorrow's exam also. So please be attentive and present on time. Okay.
Yes, sir.
Sir, may I know at what time we will have exam, sir?
It will be scheduled on second post-lunch session, but before that, there is an industry expert who would like to deliver session on IoT. So there's an industry expert who would like to deliver you an address regarding this implementation on industrial platforms regarding IoT. So post-lunch there will be a session, small session, and then after we will have an exam. So details will be shared to you tomorrow morning.
Okay, sir. Sure, sir. Thank you. Sir.
Okay. Okay.
Can you also please share the pattern, sir? Number of questions, marks.
That I will share tomorrow morning. Each and everything I will
Thank
share.
you, thank you so much. Thank you. Thank you.
Okay. Okay. Thank you. Thank you.
Okay, we'll meet